Hello, and welcome back to a quieter part of the night. For the next while, the most mind-bending alien theories explained can stay low and easy in the background. Let the day step back, let your breathing settle, and only keep the details that feel pleasant to keep. Tonight, this can be something to follow, or something to let pass by. For the next while, the most mind-bending alien theories explained can stay in the background while the small details arrive at their own pace. Take in what feels easy and let the rest move by. And before we begin, a small note of care. For the quality of your sleep, this video has been made with dim, low-light visuals, slow movement, and a soft, calm voice. Nothing here is meant to tug you awake. You can listen closely or let the details drift by. This chapter focuses on reset, the quiet puzzle of alien absence. Reset. The quiet puzzle of alien absence is why, in a universe so vast, does it feel so quiet? It existed because introduced the Fermi paradox, the contradiction between high probability and lack of evidence. The useful thing is to understand the ordinary pressure underneath it before the details start to pile up. Now, the quiet puzzle of alien absence. In plain terms, it is the mismatch between a universe that seems roomy enough for company and the fact that no confirmed company has arrived. Alien theories exist because human beings dislike an empty ledger, especially when the ledger is the size of the night sky. They give shape to a problem that is otherwise just distance, probability, and silence. An alien theory, in the broad sense, is speculation about non-human intelligence. Not just little green figures, not just silver discs, not even necessarily visitors from another planet. It can mean minds beyond Earth, minds hidden from us, minds so different that our usual words begin to wobble a little. Some of these ideas come from astronomy. Some come from folklore, altered states, military reports, bad photographs, old myths, and the very human habit of noticing patterns where the dark has left a blank space. For now, the important thing is not whether any one theory is true. Most are unproven. Some are probably wrong. A few are interesting in the way an old map is interesting. Not because it gets every coastline right, but because it shows what people were trying to understand with the tools they had. On a desk, the puzzle can look almost harmless. A folded star chart, a graphite pencil worn flat on one side, a cool mug of tea leaving a ring on the wood, a small notebook full of numbers that are too large to feel personal. Stars per galaxy. Galaxies in the observable universe. Possible planets. Possible atmospheres. Possible oceans. The figures multiply politely, column by column, until the page begins to suggest that life should not be rare at all. Then comes the absence. No confirmed signal. No agreed-upon artifact. No visitor who has politely signed the guestbook. No public, repeatable evidence that everyone can point to without argument and say, yes, that is it. The odd thing is that the silence does not feel simple. It feels almost engineered by our own expectations. We look up, we calculate, and the universe declines to answer in the format requested. This is where the famous question enters, though we will sit with it more fully next. The Fermi paradox is often described as the contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for them. Enrico Fermi, the physicist whose name became attached to the problem, is commonly remembered for asking, in essence, where everybody is. The exact conversation has been retold in different ways, as conversations over lunch often are. A napkin, a tray, a passing remark among scientists. These details have the texture of a story that became larger after the fact. Still, the question remains useful. If the galaxy is old, and stars are many, and planets are common, why does the sky behave like a locked library after closing time? A radio telescope gives the puzzle a more physical body. Think of a great dish of metal panels, bolted into a shallow bowl, tilted toward a patch of sky. Wind moves across it. Birds sometimes use it with no respect at all. Inside the equipment room, receivers turn faint radio waves into traces, files, and lists of candidate signals. The input is electromagnetic noise from space. The process is filtering, comparing, checking against interference from satellites, aircraft, weather, and human machinery. The output usually is nothing special. That usually matters. Science is good at refusing to be impressed too quickly. A spike on a screen might be a distant source, or it might be a microwave oven, a maintenance truck, a bit of electronics warming unevenly in a cabinet. I find this practical skepticism oddly comforting. It is not glamorous, but it is honest. Before a mystery can become cosmic, someone has to ask whether a cable was loose. The alien absence also depends on scale, and scale is unfriendly to the human nervous system. Light from the moon reaches Earth in a little over a second. Light from the sun takes minutes. Light between stars takes years. Across the Milky Way, it takes tens of thousands of years. A civilization could send a message at the wrong century, in the wrong direction, with the wrong kind of signal, and we would never know they had tried. Or we could be the ones transmitting from a tiny blue dot, while no one nearby has the right receiver pointed at us. This is not a dramatic failure. It is more like missing someone at a train station because one person waited by the clock and the other waited by the east doors. Only the station is made of spiral arms, dust lanes, magnetic fields, and cold hydrogen gas. A useful detail to remember is that absence is not the same as proof of absence. Empty shelves in one room do not prove the whole house is bare, but it is also true that wanting shelves to be full does not fill them. That is the trade-off at the center of this subject. Curiosity keeps the door open. Evidence decides what may enter. Many alien theories begin in that narrow space between openness and evidence. If nobody has appeared, perhaps they are too far away. Perhaps life is rare after all. Perhaps intelligence does not last long. Perhaps advanced civilizations choose not to announce themselves. Perhaps they do not use radio. Perhaps we are listening for drum beats in a world of fiber optics, or smoke signals in a world of neutrinos. Some of these possibilities are sober. Some become strange very quickly. The mind, given enough darkness, is a generous inventor. What makes this useful to remember is that the puzzle is not only scientific, it is emotional too. A silent universe can feel peaceful on one night and unsettling on another. It can make Earth seem precious, like a small kitchen window lit in winter. It can also make us wonder whether we are early, late, overlooked, protected, ignored, or simply ordinary. None of those feelings prove anything, but they explain why the question keeps returning. People have always lived with horizons. The sea horizon once held monsters, islands, gods, trade routes, and weather. A forest edge could hold ancestors, animals, spirits, bandits, or just more trees. Space is the modern horizon, with better instruments and colder temperatures. We have spectrometers now, orbital telescopes, planetary probes, databases, clean rooms, vacuum chambers, and engineers wearing lint-free gloves. Yet the old shape of the question survives. Who else is out there? And why have they not stepped into view? The record, for now, stops at ambiguity. There are intriguing signals, debated sightings, suggestive chemistry on distant worlds, and billions of planets inferred by careful measurement. There are no confirmed neighbors. That is a plain sentence, but it carries a surprising weight. So the first reset is simple. Alien theories are not all the same kind of claim. Some are mathematical guesses. Some are cultural mirrors. Some are attempts to explain odd reports. Some are modern myths wearing the fabric of science fiction. In the chapters ahead, the ideas will become more specific, and in some cases, much stranger. But underneath them all is this original absence, a vast universe, a listening species, and a silence broad enough for almost any story to echo inside it. This chapter focuses on the Fermi paradox. The Fermi paradox is the puzzle of why, in a galaxy with so many stars and so many possible worlds, we have not found clear evidence of extraterrestrial life. It exists because the numbers seem to invite company, while the evidence remains stubbornly blank. For people who study the sky, it gives shape to a very plain question. If life can happen elsewhere, why does the night appear so still? The famous version of the question is usually traced to Enrico Fermi, the physicist, during a lunch conversation at Los Alamos in 1950. The setting matters a little, I think, because it was not a grand declaration at a podium. It was lunch. Trays, cutlery, cigarette smoke, coffee cups, the small clatter of scientists taking a break from serious work. The story goes that Fermi and several colleagues were talking about flying saucers, space travel, and the possibility of life beyond Earth, when Fermi asked, in one form or another, "Where is everybody?" It is a wonderfully compact question, not polished, not mystical, almost impatient in the way a practical person might ask why a machine has not arrived from the workshop. If the galaxy is old, and stars are numerous, and travel between stars is difficult, but perhaps not impossible over long enough times, then why is there no obvious sign? No visiting craft on the White House lawn? No confirmed beacon from another star? No unmistakable artifact parked in orbit with a label, a serial number, and perhaps a rather dull maintenance panel? The odd thing is that the paradox does not require us to believe in aliens. It begins with more ordinary ingredients. The Milky Way contains hundreds of billions of stars. Many of those stars have planets, Since the 1990s, astronomers have found thousands of exoplanets using patient methods like watching a star dim slightly when a planet crosses in front of it, or measuring a tiny stellar wobble caused by the pull of an unseen world. The measurements are delicate. A graph drops by a fraction. A line on a screen shifts. A distant planet, which no human eye has seen as a solid place, becomes part of a catalogue. That catalogue is one of the reasons the silence feels different now than it may have felt in Fermi's day. In 1950, planets beyond the solar system were still mostly inferred, imagined, or argued about. Today, they sit in databases with orbital periods, estimated sizes, and star names that sound like inventory tags. Kepler, this. TRAPPIST, that. Proxima b. A softly glowing globe with pins marking exoplanets would soon look overfilled, like a map in a travel office run by someone who has never gone home. From those numbers, the mind begins to make a simple chain. Stars are common. Planets are common. Some planets may be rocky. Some may orbit at distances where liquid water could exist. Chemistry, given time and energy, can become complicated. On Earth, at least, complication eventually produced bacteria, forests, cuttlefish, radio transmitters, and people who misplace telescope lens caps in cold observatories at 3 a.m. But then the chain stops. Or seems to. We have no confirmed signal from another technological civilization. We have no accepted evidence of a spacecraft from another star system visiting Earth. Astronomers have found strange objects, unusual emissions, puzzling patterns, and many false alarms, but nothing that has settled the matter. This is where the paradox lives. Not in proof that we are alone, and not in proof that we are surrounded, but in the uncomfortable space between expectation and observation. A useful way to picture it is like a calm diagram. Input: a vast galaxy with many stars and many planets. Process: assume that life, intelligence, or technology may arise more than once. Output we might expect: signals, probes, engineering traces, or some other mark of activity. Limitation: we have not found anything confirmed. The machine is simple, almost too simple, and yet the result is strange. The silence is not absolute, of course. Space is full of soundless activity, if we use sound loosely. Pulsars keep time with lighthouse precision. Stars flare and collapse. Dust clouds glow in infrared. Hydrogen whispers at radio wavelengths. Our instruments gather all of this through metal dishes, cooled detectors, fiber optic cables, and hard drives in rooms with humming fans. What is missing is not noise. What is missing is intention. That distinction matters. A natural signal can be beautiful and still not be a message. A repeating pulse can come from a dead star, not a patient civilization tapping on the wall. A narrow radio spike can turn out to be interference from Earth. A satellite, a microwave oven door opened too early, or some more embarrassing little source in the machinery. I have a soft spot for these mundane explanations. They are not glamorous, but they remind us that the universe is difficult enough without our appliances joining in. Fermi's question also contains a time problem. The Milky Way is roughly old enough that if some civilizations arose long before us, they may have had millions or even billions of years to spread, signal, explore, or leave traces. Human technology is only a thin scratch on the surface of that timescale. Radio, rockets, computers, and planetary science are recent habits. A metal radio telescope dish in the desert is a very new kind of ear. So one side of the paradox says, if anyone got started early, they should have had time. The other side says, perhaps time is not enough. Interstellar distances are not theatrical distances. They are not just far in the way another continent is far. They are cold, empty, radiation-crossed, and expensive in energy. Even light, that fast courier, takes years to cross to the nearest stars. A spacecraft is slower. A signal weakens. A civilization changes. Budgets get cut. Antennas rust. People, or whatever people become elsewhere, may lose interest. This is one of the quieter human trade-offs inside the Fermi paradox. We often imagine advanced life as automatically expansionist, as if intelligence must always become louder, larger, and more visible. But that may be our own age speaking through a megaphone. A species could be intelligent and inward-looking. It could be cautious. It could communicate in ways we have not learned to notice. It could decide that broadcasting into the dark is unwise, though that darker possibility belongs more fully to later explanations. For now, the important point is that silence is not one thing. It can mean absence. It can mean distance. It can mean bad timing. It can mean that our instruments are too young, too narrow, or tuned to the wrong kind of evidence. A listener with a crystal radio in 1910 would not conclude that the modern internet does not exist. They would simply lack the right receiver, the right language, the right assumptions. The comparison is imperfect, but useful. Every search tool has a shape, and the shape decides what can be found. There is also a small philosophical ache here. Humans are used to being answered. A baby cries and someone comes. A letter is sent, and sometimes a reply returns. A knock at a door produces footsteps, or at least the awareness that no one is home. But the sky does not behave like a door. It does not confirm whether it heard us. It offers meteor showers, aircraft lights, satellites moving steadily after sunset, and the pale grain of the Milky Way where the air is dark enough. It gives us plenty to look at, but not the one answer the question asks for. What makes the Fermi paradox useful to remember is that it keeps two habits in balance. It prevents the easy assumption that the galaxy must be crowded in ways we would immediately recognize. It also prevents the easy assumption that our current silence proves much at all. We have listened briefly from one small planet with instruments built out of aluminum, glass, copper, silicon, and hope. That is both impressive and modest. The record at present simply stops short of confirmation. There are candidates, rumors, odd signals, and memorable nights at observatories, but no settled discovery. The paradox remains less like a locked door and more like a long hallway with many closed rooms. Some may be empty. Some may contain explanations we have not earned yet. Some may only contain our own expectations, folded neatly and left on a chair. One way people try to answer this silence is to ask whether something prevents civilizations from becoming visible at all. But that is a different question. For now, Fermi's lunchtime puzzle remains on the table, beside the cooled coffee and the dented tray. So many stars, so many possible worlds, and still no clear reply. This chapter focuses on the Great Filter. The Great Filter is a proposed barrier that stops most life, or most intelligent life, from becoming a galaxy-spanning civilization. It exists as an idea because the universe looks old, wide, and chemically generous. Yet we do not see obvious neighbors. It gives people a way to ask, very plainly, whether something difficult usually happens before civilizations can announce themselves across the stars. A useful image for it is a stack of old yellowing envelopes sealed with dull red wax, sitting in a metal filing tray. Each envelope is a stage, chemistry becoming biology, single cells becoming complex cells, creatures becoming toolmakers, toolmakers becoming radio users surviving their own inventions. Most of the envelopes in this theory are never opened. The odd thing is that we do not know which sealed envelope matters most. The Great Filter is related to the Fermi paradox, but it is more specific. The paradox asks, where is everybody? The filter asks, what step is so hard that almost nobody gets past it? That small change in wording matters. It turns the silence of space from a mystery of distance into a mystery of sequence, almost like following a recipe and wondering which instruction usually ruins the bread. The first possible filter may be the beginning of life itself. A planet can have rock, water, carbon, sunlight, tides, and heat from its interior, and still not necessarily produce living cells. Early Earth had minerals, shallow pools, deep sea vents, lightning, ultraviolet light, and a great deal of chemical patience. Somewhere in that mixture, molecules began copying themselves with enough reliability to count as heredity. We do not yet know how common that step is. In a laboratory, a glass flask can be warmed, stirred, and watched for months, with rubber tubing smelling faintly of solvent, and still the leap from chemistry to life remains difficult to pin down. If that is the filter, then Earth is not ordinary. It is lucky in a very old mineral way. The galaxy might contain many wet planets with clouds and shorelines, but most of them may be silent ponds, not nurseries. This version is almost comforting, in a strange fashion, because it places the hardest barrier behind us. We would be rare because life itself is rare, not because disaster waits at every higher step. Another possible filter is complex life. For much of Earth's history, life was microbial. Single-celled organisms did astonishing work, though they did it without skeletons, eyes, hands, or written complaints about the weather. They changed the atmosphere, altered rocks, and left chemical traces in stone. But complex cells, with internal structures like mitochondria, appear to have required unusual cooperation. One cell living inside another cell is not the sort of arrangement that sounds stable at first. It sounds more like a roommate situation that should have failed by Tuesday. And yet, In our history, that partnership became essential. More energy inside cells allowed larger bodies, nervous systems, movement, and eventually animals that could notice a horizon. If this step is rare, then the universe may have many living worlds covered in mats, films, and soft microbial skins, but very few creatures looking up. I find this possibility interesting because it reminds us that intelligence is not the obvious goal of biology. A bacterium is not a failed philosopher. It is a successful bacterium. A later filter might be intelligence itself. Brains are costly. They need calories, protection, long childhoods, and social tolerance for rather helpless young. A large brain is a warm, fragile organ inside a hard case of bone, and evolution does not hand those out as trophies. It trades. Better memory may come with slower development. Better planning may come with anxiety about winter, rivals, and missing tools. Intelligence may emerge only when the benefits outweigh the trouble. On Earth, many animals are clever in their own ways. Crows bend wire. Octopuses open jars. Elephants remember paths to water. Whales carry songs through dark water over huge distances. But technological civilization required a particular bundle: hands or hand-like tools, fire, language, teaching, social memory, and access to materials that could be shaped. Clay, bone, flint, copper, iron, wood, fiber, charcoal. Not just thought, but thought with a workshop. That is one of the small, practical truths I like about this subject. A species cannot build a radio telescope with intelligence alone. It needs oars in reachable ground, fuel, stable seasons, apprentices, measuring rods, and someone willing to polish a mirror or wind copper wire for hours. The mind may be cosmic, but the screwdriver is local. The filter may also lie in technology. A civilization can discover radio, chemistry, engines, electronics, and nuclear physics in a narrow span of time. Those tools extend perception and power. They also create new risks. The great filter does not require a dramatic ending in every case. It could be slower and more ordinary than that. Depleted soils, brittle supply chains, institutions unable to manage inventions, or 1,000 small failures of coordination. A civilization might not explode. It might simply become too complicated to maintain. In this version, the filter is a systems problem. Input. A clever species with energy sources and tools. Process. Rapid growth, invention, competition, and environmental pressure. Output. Either long-term stability or breakdown. Limitation. Intelligence does not automatically produce wisdom, and knowledge does not automatically produce restraint. That may sound severe, but it is not really a prophecy. It is just an uncomfortable engineering note written in the margin. Some thinkers worry most about where the filter sits relative to us. If the hardest steps are behind us, then our existence is evidence that we have already passed through narrow gates. Life, complex cells, intelligence, technology. If the hardest step is ahead, the silence becomes less reassuring. It may suggest that civilizations often reach something like our stage, send a few signals into the dark, build observatories and satellites, and then fail to become durable. This is where the idea gains its quiet unease. Not because it proves danger. It does not. The evidence is too thin, and absence is a slippery kind of evidence. A radio receiver in a dry valley, turning its dish toward a cold patch of sky, may hear nothing for reasons that have nothing to do with filters. Signals may be weak, brief, badly timed, or unlike anything we know how to recognize. The record simply does not let us speak with confidence. Still, the great filter is useful because it makes the question less vague. It asks us to place difficulty somewhere along the chain. Is the hard part making life from chemistry? Is it making complex cells? Is it surviving intelligence? Is it learning to live with tools powerful enough to change the planet that made them? Each answer has a different emotional temperature. If the filter is early, we may be alone in a way that makes Earth feel more precious. Not precious in a sentimental poster sense, but precious like a working pocket watch found in a drawer after a house move. Small gears still turning against the odds. If the filter is late, then the task is not to become more brilliant exactly. Brilliance may be part of the problem. The task would be to become steadier. A desk covered in old envelopes is not a telescope, but it captures something the telescope cannot. It shows delay. It shows stages. It shows the possibility that most messages never get written, never get addressed, never leave the table. Somewhere between warm ponds, stone tools, circuit boards, launch pads and radio dishes, the line may narrow. We do not know where. That is the important part, and maybe the most honest one. The great filter is not proof that others are gone, or that we are doomed, or that Earth is the only inhabited place. It is a careful name for a missing answer. A barrier may stand behind us, ahead of us, or scattered in many smaller barriers across time. For now, the envelopes remain sealed. The wax is cracked at the edges. The labels are written in a hand we can almost read. And beyond the desk, beyond the roof, beyond the atmosphere, the stars keep their distance while the question waits for the next chapter to take a slightly different shape. This chapter focuses on the zoo hypothesis. The zoo hypothesis is the idea that advanced extraterrestrial civilizations may know about Earth, but deliberately avoid direct contact with us. It exists as one possible answer to the problem of cosmic silence. Perhaps the silence is not emptiness, but restraint. In plain human terms, it suggests that we may be interesting enough to observe, but not yet considered ready or appropriate to interrupt. The image is almost too neat, which is one reason I treat it carefully. A planet becomes a kind of protected enclosure, not a cage with bars exactly, but something more like a field station, a wildlife reserve, or a glass-covered terrarium on a desk, misted and green, with beads of water clinging to the inside. The moss grows. A small beetle moves beneath a curled leaf. Someone nearby has a clipboard, perhaps, and a habit of not tapping the glass. That last part matters. The zoo hypothesis is not mainly about alien spaceships hiding behind the moon, or dramatic visitors in polished metal craft. It is about policy. It imagines rules. It imagines a civilization old enough, organized enough, and perhaps patient enough to say, "Do not interfere. Watch, measure, listen, record, but do not step into the habitat and start explaining the stars to the animals. The astronomer John A. Ball is often associated with the idea, writing about it in the 1970s as one possible response to the wider silence of the universe. The proposal was speculative then, and it remains speculative now. There is no solid evidence that Earth is under observation by extraterrestrial caretakers. No recovered memo from a galactic park service. No visitor's guide with Earth circled in blue ink. Still, as a thought experiment, it has a certain stubborn usefulness. It asks not only where they are, but what manners they might have. A zookeeper, after all, does not usually climb into the enclosure just to introduce herself. A wildlife biologist watching nesting birds may sit for hours in a canvas hide that smells faintly of damp fabric, mud, and old coffee. The whole point is to reduce disturbance. Binocular lenses are wiped with a cloth. Boots are kept off dry twigs. A field notebook is opened slowly, because even a small crackle of paper can change an animal's behavior. That is the softest version of the theory. Advanced beings might be curious, but cautious. They might consider open contact a form of contamination. If a younger civilization learns too much too quickly, it may stop becoming itself. Its religions, languages, markets, arguments, machines and mistakes might all bend around the presence of the outside observer. Even a kind visitor can become the center of the room. I find that detail important because kindness does not always solve the problem of interference. Sometimes the kindest act is also the most frustrating one. Staying back. The mechanism, if we draw it like a calm diagram, is simple. Input. A developing planet with life, tools, radio noise, cities, oceans, quarrels, music, and weather satellites. Process. An older intelligence detects it, classifies it, and chooses observation rather than engagement. Output. We see no clear signal, no formal greeting, no unmistakable artifact. Limitation. From inside the enclosure, non-interference and absence look almost exactly the same. That is the difficulty. A perfectly hidden observer leaves no evidence by design. If there are footprints in the snow, the observer was careless. If there are no footprints, the observer may not exist at all. The theory is built around a silence that cannot easily be separated from ordinary silence. This is where a little skepticism is not rude. It is just good housekeeping. A hypothesis that explains every lack of evidence can become too comfortable in its own chair. And yet, the emotional shape of it is hard to ignore. Human beings already understand watching without touching. We do it in museums, behind velvet ropes and glass cases. We do it with tide pools, leaning over wet stone while trying not to crush the barnacles under our shoes. We do it in laboratories with sealed petri dishes, white labels, and careful handwriting. We have learned, unevenly and imperfectly, that to study something is also to risk changing it. The zoo hypothesis takes that ordinary rule and stretches it across interstellar space. Perhaps Earth is not ignored. Perhaps it is protected. Perhaps, somewhere beyond our instruments, there is a patient archive of our radio broadcasts, our methane levels, our night-side lights, our first awkward steps beyond the atmosphere. I do not quite believe this in any firm way. but I understand why the image lingers. It turns the coldness of space into something with intention behind it, and intention is easier for the mind to hold than indifference. A small irony sits inside the idea. If we were being watched, our privacy would be violated and preserved at the same time. No one speaks to us. No one lands in the town square. Our history remains, at least on the surface, our own. And yet the thought of unseen observers makes even ordinary things feel slightly theatrical. A traffic light changing at an empty intersection, a child dropping a spoon from a high chair, a radio telescope in Puerto Rico or Australia turning its broad dish toward a clean patch of sky. The theory also raises the question of what counts as maturity. Would an observing civilization wait for a certain technology, such as stable interstellar travel? Would they wait for political unity, if such a thing is even realistic? Would they look for signs that a species can handle knowledge without turning it instantly into a weapon, a commodity, or a slogan? That last possibility feels uncomfortably plausible. Not because it proves anything about aliens, but because it says something fairly plain about us. A human zoo has feeding schedules, locks, drainage channels, veterinary rooms, steel gates, and a small office where someone keeps records in a cabinet. A cosmic zoo, if such a thing existed, would have stranger tools. Sensors placed far beyond Earth. Algorithms listening to the scratch and murmur of our electromagnetic leakage. Agreements among civilizations, perhaps, about when contact is allowed. Or perhaps there would be no agreement at all. Only one powerful culture deciding that observation is best. The word zoo sounds tidy, but the ethics are not tidy. This is where the hypothesis becomes less cozy. Zoos have histories, and not all of them are noble. Observation can protect, but it can also reduce a living being to an exhibit. A reserve can be sanctuary, or it can be control with better language. If Earth were being watched, we would not know whether we were respected, studied, pitied, or merely catalogued. The record, if there is one, is not open on our desk. Still, the most interesting part may be the rule against contact itself. A civilization capable of crossing enormous distances or sending instruments across them might also be capable of patience on a scale we barely understand. We are used to short projects, grant cycles, elections, school years, battery life, the time it takes for a kettle to click off in a kitchen. A species 1 million years older might consider 10,000 years a reasonable observation period. They might look at human history the way a botanist looks at a seed tray, noticing the first green bend of a stem and deciding, not yet. And of course, the simplest explanation remains available. Maybe no one is watching. Maybe the terrarium is just a terrarium. The glass is only glass. And the silence above us is not a policy, but a distance. That possibility has its own dignity. Not every closed door has someone standing behind it. So the zoo hypothesis leaves us with a peculiar kind of cosmic privacy. We may be alone, or we may be uncontacted. We may be overlooked, or carefully left alone. From our side, the night sky looks the same either way. Dark, spacious, pricked with old light, offering no clarification. And perhaps that is why the idea stays with people. It gives the universe a face just out of view, then asks us to go on living as if no one is there, which is, practically speaking, what we were doing anyway. This chapter focuses on the crypto-terrestrial hypothesis. The crypto-terrestrial hypothesis is the idea that some non-human intelligence might already live on Earth, hidden from ordinary human view. It exists as an alternative to the usual picture of visitors arriving from distant stars in metal craft. Instead of asking how something crossed interstellar space, it asks a stranger, more local question. What if the neighbors were here before we noticed the neighborhood? The word itself sounds a little awkward, almost like a label on a drawer in a museum basement. Crypto, hidden, terrestrial, of the Earth. Hidden Earth beings. I find the term inelegant, but useful in the way a pencil mark on a faded map is useful. It does not prove there is a tunnel under the hill. It only says, someone wondered enough to draw one. The idea overlaps with older writings by people like John Keel, who explored unusual encounters in a way that did not always fit the simple alien spacecraft model. Keel used the term ultra-terrestrial for beings that seemed, in his view, to operate near human life while remaining elusive, theatrical, and oddly symbolic. Later writers developed the more specific crypto-terrestrial idea, not necessarily beings from another planet, and not quite spirits either, but a hidden population sharing the same planet under conditions we do not understand. That is the first strange turn. The theory makes Earth itself feel less familiar. A field is not just a field. A cave mouth is not just damp limestone and fallen leaves. A dark ridge beyond a logging road. A sealed mine entrance with a rusted chain. A patch of sea where the sonar returns go fuzzy for ordinary reasons. All become, in the imagination, possible edges of someone else's country. Most versions of the hypothesis place these hidden neighbors in places humans do not easily occupy. Underground is the obvious one. Caves, lava tubes, abandoned mines, deep bunkers, cavities in mountain ranges. Earth has many hollow spaces, though not nearly enough to support the grander fantasies people sometimes attach to them. Real caves are inconvenient. They flood. They collect carbon dioxide. They smell of wet stone, clay, and old mineral water. A civilization hidden underground would need air, heat management, waste handling, food, repair shops, and some way of keeping its doors from being found by bored hikers with headlamps and too much confidence. That practical side matters. It is one of the best ways to keep this theory from floating away completely. If something lives here, it must deal with here. Mud on boots, corrosion on metal, the weight of rock, the dull, unromantic problem of ventilation. Even a very advanced hidden intelligence would still have to contend with physics, unless the story quietly changes into something else. Underwater habitats appear in some versions too, though the larger mystery of objects entering or leaving the sea belongs to another chapter. For this idea, the ocean matters because it is still difficult territory for human beings. We map the seafloor better than we once did, but it remains a cold, heavy, pressure-filled place. A few miles down, machinery creaks. Lights show only a small cone of suspended particles, and communication becomes slow and awkward. If a hidden society wanted privacy, water would be a superb curtain, not a magical one, just a very large, very heavy one. Remote wilderness plays a similar role. Northern forests, desert basins, mountain valleys, marshes, old rural roads where telephone poles lean slightly, and the gravel has been washed into ribs by rain. These are places where stories can survive because ordinary checking is hard. A light seen above a tree line may be a vehicle, a drone, a planet, an aircraft, a reflection, a misremembered detail, or something genuinely unexplained. The record often narrows to a witness, a location, and a feeling. Some accounts simply stop there. What makes the crypto-terrestrial idea especially interesting is how easily it blends with folklore. Before modern UFO language, many communities told stories of fairies, little people, hidden folk, forest beings, household spirits, lights in bogs, tricksters, ancestors, angels, demons, or presences that lived just beyond the edge of ordinary rules. These traditions are not all the same, and it would be careless to flatten them into one global category. But the pattern is worth noticing. Human beings, in many places and eras, have described intelligent others who are nearby, secretive, powerful in odd ways, and not quite part of public daylight life. The costume changes with culture. In one century, the visitor wears green or lives under a hill. In another, it has large, dark eyes and arrives beside a road. In one account, the encounter is framed as a spirit visitation. In another, as a craft, a hatch, a humming sound, a memory gap. I do not think this proves a single hidden species is walking through all of history wearing different masks. That would be far too neat. But it does suggest that the human mind has a long-standing category for intelligence close by, but inaccessible. This is where altered states sometimes enter the conversation. Carefully. People under the influence of certain mushrooms or psychedelics have reported encounters with small beings, elves, helpers, tricksters, or intricate mechanical presences. Those reports belong more fully with the later discussion of visionary entities, but they brush against the crypto-terrestrial idea because they raise the same awkward question. Are people meeting something outside themselves? Or are they seeing symbolic life generated by the brain under unusual pressure? The evidence does not let us answer that cleanly. It only gives us repetition, and repetition is not proof, though it is rarely nothing. A small desk detail comes to mind here. Old researchers and enthusiasts often worked with folders, index cards, newspaper clippings, and maps marked in pencil. A red circle around a farm road. A note beside a cave system. A date copied from a local paper. The corners curl. The tape yellows. Patterns begin to appear. Partly because something may be there, and partly because the human hand is very good at drawing lines between dots. That is not a flaw exactly. It is how investigation begins. It is also how it can mislead itself. The strongest objection to the crypto-terrestrial hypothesis is simple. There is no solid public evidence for it, no confirmed habitat, no recovered tool that clearly belongs to a hidden, non-human technology, no biological sample. no reliable chain of custody, no entrance found behind a basalt wall with a working machine inside. What we have are stories, patterns, interpretations, and the unsettling durability of the idea. Still, the emotional force of the theory is not hard to understand. Aliens from far away are strange, but they are distant. Hidden neighbors are intimate. They change the meaning of home. A child hears a sound beneath the floorboards and imagines something living under the house. An adult looks at a mountain, an ocean trench, a military map, a locked steel door in a service corridor, and feels a more elaborate version of the same thought. What else is already here? The most unsettling version is not that such beings would be hostile. That is the louder story, and often the less interesting one. The stranger possibility is indifference. If something older or more advanced had been sharing the planet quietly, it might see us as young neighbors, noisy tenants, clever animals, or simply a weather pattern that builds cities. The practical irony is almost domestic. If you discover another intelligence in your own house, the first question is not cosmic. It is about boundaries. And perhaps that is why this theory lingers. It makes the familiar slightly porous. The map on the desk still shows coastlines, roads, rivers, rail lines, and shaded relief. But the penciled tunnels remain in the margin, uncertain and faint. No one has proven they lead anywhere. Yet once you have seen them, the blank spaces on Earth feel a little less blank, and the next strange theory can enter through that narrow opening. This chapter focuses on interdimensional visitors. Interdimensional visitors are hypothetical beings or objects that would come not from another planet in our space, but from another layer, direction, or version of reality. The idea exists because it tries to solve a practical puzzle in unusual reports. Why some strange things seem to appear, behave impossibly, and then vanish without leaving ordinary traces. Instead of imagining a metal craft crossing light years, this theory imagines a kind of crossing between worlds. A simple object helps here. A glass prism on a desk can take one white line of sunlight and spread it into red, orange, yellow, green, and blue across a stack of notebooks. Nothing magical has happened. The light was always capable of that spread, but the glass revealed it by bending the path. Interdimensional theories often work in a similar mood. They suggest that reality may contain directions or layers that are not normally available to our senses, and that under certain rare conditions, something might bend through. This is not evidence, of course. It is a model. And models can be useful even when they turn out to be wrong, because they show what kind of explanation a person is reaching for. In ordinary life, space has 3 dimensions: left and right, forward and back, up and down. Add time, and physics gives us a 4-dimensional spacetime, where motion and gravity are described not just as things happening in a room, but as paths through a larger structure. A clock on a wall, a train schedule folded in a coat pocket, and a radio signal crossing a dark field all belong to this same practical fabric. They are ways of measuring where and when. Higher dimensional theories go further. In some branches of mathematics and speculative physics, extra dimensions are treated as possible, though not in the familiar sense of a hidden hallway behind the pantry. They may be curled up at tiny scales. described by equations rather than by doors. A physicist might sketch them on graph paper, with axes and symbols that look very tidy, until the idea underneath becomes almost impossible to picture. I find that mismatch rather charming. The neat pencil line trying to hold a universe it cannot really draw. For alien speculation, the appeal is obvious. If a visitor could move through a dimension we cannot access, then some impossible-looking movements might not require impossible speed. A thing might appear in one place, disappear, and show up somewhere else, not by racing across the sky, but by taking a route we cannot see. To us, it would look like a vanishing act. To the visitor, if such a visitor existed, it might be as ordinary as stepping around a table. The usual analogy is a flat world. Imagine a two-dimensional creature living on a sheet of paper. It understands length and width, but not height. If a human finger touched the page, the creature would not see a whole finger descending from above. It might see a circle appear from nowhere, grow wider, then shrink and vanish. If a coin passed through the page, the flat creature might build a careful mythology of circles. It might become a good scientist of circles, but the larger object would remain mostly unavailable. That analogy is old and a little overworked, but it still does the job. It makes the difficulty feel practical. The problem is not that the flat creature is foolish. It simply lacks the sense organ and geometry for the larger event. A human being looking at a supposed interdimensional object would have the same problem in reverse. Too little access, too much interpretation. This is where some UFO accounts become interesting to people who favor this theory. Reports sometimes describe lights that seem to blink out rather than fly away, shapes that alter their outline, or objects that appear to ignore inertia. A pilot, a farmer, a radar operator, or a night watchman might describe something that does not behave like an aircraft made of aluminum, rivets, fuel tanks, and hot engines. The interdimensional explanation says, perhaps the object is not fully inside our frame. Perhaps we are seeing a slice. That word, slice, matters. If a three-dimensional apple passes through a two-dimensional plane, each moment would show a different cross-section. First a dot, then a small circle, then a larger one, then the shape would narrow again. Transfer that idea upward, and a higher dimensional object passing through our space might appear as changing forms. Not because it is shape-shifting in the theatrical sense, but because we only perceive the part intersecting our world. The mechanism, if we put it as calmly as possible, would be this. An object exists in a larger dimensional structure. Part of it intersects our space-time. Our instruments and eyes record only that intersection. Then the intersection changes or ends. Input, a larger object. Process, partial contact with our world. Output, a strange appearance, motion, or disappearance. Limitation. We do not have direct access to the full object, so nearly everything important remains inferred. A quiet like or subscribe helps the channel reach people who use videos this way. That last limitation is not a minor problem. It is the whole weather system around the theory. A radar return can be mistaken. A camera sensor can bloom around a bright point. Human memory can repair a confusing moment into a cleaner story afterward. Accounts disagree. The record often contains gaps, retellings, and missing measurements. And interdimensional explanations are difficult to test because they can explain almost any absence of evidence by saying the evidence withdrew into another layer. That is convenient, perhaps too convenient. If this is useful tonight, saving it for another night is more than enough. Still, I do not think the idea is silly, simply because it is hard to prove. It belongs to a long human habit of admitting that perception is narrow. We know there are colors outside the range of the eye, sounds beyond the ear, particles passing through the room without tapping politely on the furniture. A radio telescope does not see the same sky as a backyard telescope. A magnetometer does not live in the same world as a hand held up to the wind. Reality has already taught us, several times, that our bodies are not the final measuring instrument. The emotional pull of interdimensional visitors comes from that fact. It says the universe may not only be large, it may be deep. Not far away, but layered close by. The strange thing might not be arriving from the star beside another star. It might be adjacent in a way that distance does not describe. That is a different kind of loneliness, and maybe a different kind of company. At the same time, the theory asks us to be careful with language. Dimension can mean a precise mathematical direction, a physical degree of freedom, a speculative universe, or just a vague elsewhere. Those are not the same thing. A chalkboard in a university office and a late-night story told at a kitchen table may both use the word, but they are doing different work with it. I prefer when the word is handled like a sharp tool, not a decoration. It cuts better that way, and it is less likely to make a mess. Alternate realities add another layer to the idea. Some interpretations of quantum mechanics and some cosmological models have inspired talk of parallel worlds. In popular alien theories, this sometimes becomes the suggestion that visitors could come from a neighboring reality where history, matter, or life developed differently. They would not be Martians or beings from a distant exoplanet, but residents of a world offset from ours by a rule we do not understand. Here again, the evidence is thin. Physics does not currently provide a working visitor's map from one reality to another, folded neatly in a metal glove compartment. The mathematics, where it exists, is not a travel brochure, but the notion lingers because it gives a shape to experiences that feel discontinuous. A light appears over a field. A figure is seen at the edge of a road. A room seems, for 1 minute, arranged around a presence no one can name. Then the ordinary world resumes. Gravel, fence wire, cold coffee in a paper cup, the hum of a refrigerator. Some accounts simply stop there. What makes this useful to remember is that the theory changes the alien question. It does not ask only, how far away are they? It asks, what counts as away? That is a small sentence with a lot of weight in it. Away could mean 10 light years. It could mean behind a mathematical boundary. It could mean present, but not aligned. The odd logic of interdimensional visitors is that they would be both close and unreachable, near enough to touch the edge of our world, yet not necessarily available to conversation, capture, or ordinary proof. This may be why the theory often feels more like philosophy than engineering. It turns the UFO from a vehicle into a symptom of a larger reality. A mark on the page, not the whole hand. And perhaps That is where the idea can rest for now. Not as a claim we need to accept, and not as a joke we need to swat away, but as a strange little prism held up to the problem. Light enters. Something bends. A few colors appear on the paper, faint and separate, before the sun moves on. This chapter focuses on DMT machine elves. DMT machine elves are small, intelligent-seeming beings that some people report encountering during experiences with the psychedelic compound DMT. For people interested in alien theories, they offer a strange problem. Perhaps some others are not found by looking farther into space, but by altering the machinery of perception itself. They matter here because they blur the line between visitor, vision, symbol, and brain event in a way that is difficult to file neatly. The phrase is often associated with Terence McKenna, who spoke about self-transforming machine elves as though they were busy little craftsmen in a hyper-colored workshop. The wording is odd, but oddly useful. Elf gives them a folkloric size and mischief. Machine gives them a sharp, artificial quality, as if they are made of clicking parts, polished joints, and impossible instructions. In many accounts, they are not simply seen like figures in a dream. They seem to perform. They gesture, assemble, unfold, demonstrate, chatter, or present objects that cannot quite be remembered afterward. A person describing such an experience may mention jeweled patterns, rooms made of moving geometry, faces inside faces, tiny workers, carnival-like architecture, or language that arrives as color rather than sound. The details vary. Some reports feel playful. Some feel stern. Some are too abstract to summarize without sounding as if a box of stained glass, circuit boards, and toy theater props has been shaken together on a desk. A sketchbook beside a small glass vial is a fitting image for this subject. The hand tries to draw spirals, lattices, masks, and grinning little figures, but the page remains plain paper with graphite dust in the binding. The cautious explanation begins with chemistry. DMT, or N-dimethyltryptamine, is a powerful psychedelic compound found in some plants and also in trace amounts in animal bodies, including humans. Its natural role in the body is still not well understood, and the evidence does not support the more extravagant claims sometimes made about it. That is one of those places where the internet likes to sprint, while the science is still tying its shoes. In a simple diagram, the input is a compound that strongly affects serotonin receptors in the brain. The process is altered, signaling across networks involved in vision, memory, meaning, emotion, and the sense of self. The output can be a brief but overwhelming world of patterns, presences, and impossible certainty. The limitation is just as important. A vivid experience is not the same thing as independent evidence of an external being. Still, dismissing the reports too quickly misses the interesting part. The human brain does not merely receive reality, like a camera taking a photograph. It edits. It predicts. It fills gaps. Even ordinary vision is a managed construction, built from light, nerve impulses, expectation, and habit. A wooden chair in a study looks simple enough, but the mind is quietly deciding where its edges are, how far away it is, whether it is safe to sit on, and what it means as an object. And under extreme changes in perception, that same meaning-making system may produce entities. Agents with intention, faces, hands, tools, and moods. What I find interesting is how often the mind chooses company. Not just colors, not just tunnels or starbursts. Company. Small beings, teachers, tricksters, busy workers. A person might enter an altered state, expecting abstract visuals, and instead meet something that behaves like a host in a house where the wallpaper is alive. The odd thing is that even in the most alien descriptions, the social pattern is familiar. Someone arrives, someone greets, someone shows the visitor around. It is almost domestic. If the domestic world had been rebuilt out of neon embroidery and polished insect wings. If you want another one in this tone, subscribing is the easiest way to find it. Older traditions give this pattern a wider frame, though we have to be careful here. Before modern UFO language, people in many places spoke of fairies, spirits, ancestors, angels, demons, forest beings, little people, and tricksters. These categories are not interchangeable, and they belong to particular cultures, stories, and religious worlds. But from a distance, one can notice a recurring human form of encounter. A person crosses a boundary, enters a changed state or unusual place, and meets intelligences that are not quite human. Sometimes the boundary is a cave mouth, a mushroom ring, a fever, a ritual, a dream, or a lonely road at night. In the 20th and 21st centuries, the costume often changes. The visitor becomes an alien, a grey, a mantis being, an interdimensional guide, or a machine elf. A quiet like or subscribe helps the channel reach people who use videos this way. Mushrooms belong in this conversation, only with caution, but they do add a curious echo. Some people using psilocybin mushrooms report small presences, tiny figures, gnome-like beings, or a sense of intelligence in the room. Again, this is not proof of outside contact. It may be the brain under pressure, shaping uncertainty into actors. Yet the repetition is hard not to notice. The mind, given certain keys, often opens a door with little people behind it. I do not think that proves anything cosmic, but it does suggest that the category of encounter is older and broader than flying saucers. A more skeptical view says machine elves are what happens when pattern recognition, memory, visual processing, and agency detection all become intensely amplified at once. Humans are very good at detecting agents. We see faces in knots of wood, animals in clouds, a watcher in a coat hanging on a chair. This skill is useful in ordinary life. Better to mistake a shadow for a person than a person for a shadow, at least in some circumstances. Under a powerful psychedelic state, that habit may become theatrical. The brain may generate not only a pattern, but the maker of the pattern. Not only a room, but an inhabitant. A more speculative view asks whether consciousness might be less private than we assume. Perhaps altered states do not create entities, but tune perception towards some level of reality, normally screened out. This is the version that attracts alien theorists, mystics, and a few philosophers who are willing to stand near the edge of the map without pretending the edge is solid ground. The problem, of course, is evidence. If the beings cannot be reliably observed by others, cannot provide testable information, and cannot be separated from the conditions of the altered brain, then the external contact claim remains beyond our reach. Some accounts simply stop there, with a person saying, in effect, "I know what I met," and science replying, quite reasonably, "We know what we can measure." A clinical room makes this tension feel less dramatic and more practical. Picture a plain wall clock, a plastic chair, a clipboard, a pulse monitor with a soft rubber cuff, and a researcher trying to turn astonishing reports into data without flattening them completely. That is not easy work. Language is a poor container for such experiences. People reach for phrases like "more real than real," which may be sincere, but are almost impossible to verify. The researcher has to record the words anyway, because subjective experience is still a real human event, even when its interpretation is uncertain. The philosophical drift here is small but persistent. All of us live inside a controlled hallucination of sorts, if one uses that phrase carefully. A model of the world, updated by the senses, corrected by touch, sound, other people, and the stubborn resistance of furniture. Most of the time, the model behaves. The cup is where the hand expects it to be. The floor does not ripple. The face in the mirror remains our own. But the machine elf reports remind us that reality, as experienced, is always mediated. The brain is not a window. It is also a workshop. And perhaps that is why these beings have found a place in alien speculation. They are not aliens in the ordinary sense. No radar track, no landing mark, no metal fragment in a lab drawer. They are entities of testimony, memory, chemistry, and interpretation. Yet they press on the same nerve as the larger question. When we encounter something that feels other, how do we decide what kind of other it is? For now, the most grounded answer is also the strangest. Machine elves may be made by the mind, but that does not make them simple. A dream is made by the mind too. And dreams have troubled kings, comforted children, inspired mathematicians, and left ordinary people staring at the ceiling in the morning, trying to remember a sentence that seemed important. The little beings of DMT sit in that uncertain territory, not proven visitors, not meaningless noise, but figures at the edge of perception, tapping away at impossible tools, just out of reach of the waking page. This chapter focuses on underwater UFOs. Underwater UFOs, often called unidentified submerged objects, are reports of strange lights, craft, or moving targets that seem to enter, leave, or travel beneath the sea. The idea tries to solve a practical problem in UFO stories. If something can appear in the sky and then disappear, where could it go without being followed? The ocean offers an answer that is both simple and unsettling, because water covers most of the planet and keeps its own counsel rather well. After all the talk of visitors from other dimensions or beings hidden in the mind, this theory brings the mystery back to a very physical place. Salt water, steel hulls, sonar rooms, wet rope, and charts marked with pencil. It is less about cosmic philosophy and more about a hard edge on the map, where the land stops and instruments begin to disagree. The term USO has a slightly awkward sound, like something stamped on a naval form and filed in the wrong drawer. But the idea behind it is durable. Pilots have reported lights that appear to descend toward the surface, Sailors have described glowing shapes under dark water. Radar operators and sonar technicians have, at times, recorded targets that seem to move in ways they could not easily explain. Most of these accounts are fragmentary. A few minutes on a screen, a witness statement, a line in a logbook, a position noted near a coastline, then nothing. What I find interesting is that the sea does not need aliens to be mysterious. It already has pressure, darkness, currents, thermal layers, wreckage, whales, submarines, volcanic vents, drifting equipment, and weather doing complicated things at the surface. A sonar return is not a photograph. It is an interpretation of sound. A pulse goes out. Something reflects it, and a system turns that echo into a shape or trace. The input is noise moving through water. The process is filtering and calculation. The output is a mark on a screen. The limitation is that water is not a clear window. It bends, muffles, and lies by accident. In a sonar room, the mystery would not look like a shining saucer at first. It might look like a smudge of green light, a moving dot, or a line that refuses to behave. The air would smell faintly of metal, warm electronics, coffee gone bitter in a paper cup, and the damp wool of someone's jacket. A technician might lean closer, not dramatically, just with the tired posture of a person who has watched too many screens. Then comes the ordinary question. Is it a submarine, a school of fish, a sensor fault, a layer of colder water, or something else? That something else is where USO stories live. One of the more famous cases often connected with underwater UFO lore is the 1967 Shag Harbour incident in Nova Scotia. Witnesses reported lights in the sky that seemed to descend into the water near the harbour. Search efforts followed, involving local people and authorities, but no conventional wreckage was found. The record does not give us a clean answer. It gives us a cold coastal village, dark water, official uncertainty, and a story that kept its shape over time. That is often how these cases survive. Not because they prove something, but because they resist becoming tidy. Modern reports sometimes place the same kind of strangeness near naval training areas or coastal airspace. In discussions of UAPs, people occasionally speak of transmedium objects, meaning objects that appear to move between air and water. The claim is extraordinary, and the evidence has not caught up with the claim. Still, the concept has a peculiar engineering appeal. Air and water are very different materials to travel through. Air is thin and forgiving. Water is dense, heavy, and punishing. A machine built to move smoothly through both would have to solve problems that our own vehicles usually separate into categories. Aircraft here, submarines there, ships in between. This is the practical reason the theory catches the imagination. If a craft could pass from sky to sea without slowing, breaking apart, or leaving obvious debris, it would not merely be a better airplane. It would be using physics in a way we do not yet understand, or at least in a way we do not publicly use. The dull engineering question becomes the strange one. How do you build something that treats the ocean's surface not as a barrier, but as a doorway? Still, the ocean is also a perfect cloak for ordinary uncertainty. A radar trace can be misread. A flare can reflect on low cloud. A meteor can seem to fall into the water. Bioluminescent plankton can glow when disturbed, turning a wake into a pale green scene. Submarines, research drones, weather balloons, classified aircraft, fishing gear, and even unusual wave patterns can all contribute to reports that feel stranger in memory than they were in the moment. This is not a dismissal. It is just the inconvenient truth that good hiding places also make poor evidence. I have a small preference in these stories for the boring details. The brass compass beside a weathered nautical logbook, the grease pencil mark on a chart table, the old habit of recording time, bearing, speed and sea state, even when nobody knows what they have seen. Those details do not make a mystery true, but they make it more useful. They give it handles. Without them, a story becomes mist. With them, at least it can be held up to the light for a while. Some recent reports from coastal areas, including places like New Jersey, have included claims of unusual lights appearing near or over water. Other accounts come from rural shorelines, fishing communities, and northern regions of Canada, including stories told in and around indigenous communities today. These should be treated carefully, not as exotic decorations for a mystery, but as local accounts from people who know their skies, rivers, and working landscapes. A person who lives by water often notices the difference between a common boat light and something out of place. That does not settle the question. It does mean the witness is not automatically naive. The sea has always been a kind of second sky. Sailors navigated by stars reflected on black water. Navies learned to listen through hydrophones and sonar arrays. Oceanographers lower instruments into trenches where sunlight never arrives. A strange thing seen overhead can feel distant, almost theatrical. A strange thing beneath the hull feels nearer. The floor is moving. The boat is small. The darkness is not above you, but under your boots. And perhaps this is why underwater UFO theories feel different from ordinary UFO stories. They shift the unknown from out there to down there. The mystery is not crossing interstellar emptiness. It is sharing our planet's basement, slipping through trenches, shelves, seamounts, and cold blue corridors. If one wanted to hide advanced technology on Earth, the deep ocean would be a reasonable place to imagine. Not proof, not even close. But as a hiding place, it has advantages. No roads, no windows, very few witnesses. Immense pressure as a natural fence. The odd thing is that our maps of the ocean are both impressive and incomplete. Satellites can measure sea surface height. Ships can map the seafloor with multi-beam sonar. Autonomous vehicles can crawl through underwater terrain with cameras and sensors. And yet, compared with the land, the deep ocean remains difficult, expensive, and slow to inspect. A research vessel burns fuel by the hour. A remotely operated vehicle needs cables, pilots, maintenance, and calm enough conditions to launch. Salt water corrodes everything eventually. Even curiosity has a budget. So the USO theory sits in a narrow gap. On one side, there is no recovered alien machine, no public artifact, no clear physical proof that something non-human is moving under the waves. On the other side, there are enough strange reports, sensor anomalies, and unresolved accounts to keep the question from feeling entirely empty. Evidence points mostly to ambiguity. Some accounts become explainable. Some become less impressive when examined closely. Some simply stop there, at a screen, a splash, a light, a note in a file. Maybe that is the most honest shape of this chapter. The ocean does not confirm the theory, but it gives the theory a place to breathe. It is vast enough for speculation and harsh enough to humble it. Every claim has to pass through water, pressure, darkness, and the stubborn demand for proof. For now, underwater UFOs remain a mystery of surfaces. Sky meeting sea, witness meeting instrument, story meeting record. A light descends. A sonar mark moves. A sailor writes something down. Then the water closes, as water tends to do, leaving only the chart, the echo, and the faint impression that the planet still has rooms we have not properly entered. This chapter focuses on the Black Knight satellite. The Black Knight satellite is a modern space legend about a mysterious object said to be orbiting Earth, sometimes claimed to be 13,000 years old, and possibly alien in origin. The story gave people a way to connect scattered oddities. Strange radio signals, unclear photographs, Cold War tracking reports, and the simple unease of knowing that things can circle above us unseen. In plain human terms, it turns orbital confusion into a watcher. A useful image for it is not a glowing saucer or a silver craft, but a dusty model of an old satellite perched on a bookshelf. A little thing with spindly antennae, dull metal panels, and a base that has gone slightly yellow with age. It sits between a paperback astronomy guide and a box of spare screws, looking more like a school project than an emissary from another star. That, to me, is part of the charm of the Black Knight story. It is grand and cosmic in claim, but oddly domestic in the evidence people point to. Photographs, radio logs, newspaper clippings, and objects that might simply be bits of hardware. The legend does not begin in one clean place. It gathers itself slowly, like lint in a coat pocket. Some versions reach back to Nikola Tesla and his experiments in Colorado Springs in 1899, when he reported receiving unusual radio signals. Tesla was working with tall coils, wires, sparks, and a laboratory full of ozone and hot metal smell. He thought he may have detected something unnatural, perhaps even signals from another world. Later retellings sometimes fold this into the Black Knight narrative, though the connection is not firm. A signal heard by Tesla is not the same thing as a satellite in orbit. Still, legends are not strict archivists. They borrow what glimmers. Another thread comes from the early study of long-delayed radio echoes, or signals that seem to return after a strange pause. In the 1920s, experimenters noticed that some radio transmissions appeared to echo back seconds later, longer than ordinary reflections would suggest. A simple version of the mechanism goes like this. A transmitter sends out a pulse. The signal moves through the atmosphere and near-Earth space. Something reflects or refracts it, and a receiver hears it again. The problem is that space weather, ionized layers of the atmosphere, equipment quirks, and timing errors can all complicate the result. Input, delay, return. But the limitation is the important part. Early radio work was full of interference, static, and instruments that demanded patience. A scratchy signal in headphones can feel like a message if you are already listening for one. In the 1970s, a Scottish writer named Duncan Lunan suggested that some long-delayed echoes might be interpreted as a kind of star map, possibly sent by a probe from the region of Epsilon Boötis. This interpretation is often linked to the 13,000-year figure in the Black Knight legend. Lunan later distanced himself from some of the more extravagant versions, but by then the idea had already entered the bloodstream of space folklore. It had a satisfying shape: an old probe, a hidden message, a patient machine waiting above Earth since before recorded civilization. I find it interesting that the number 13,000 does a lot of emotional work here. It is old enough to feel mythic, but not so old that imagination loses its grip. Cold War confusion added more material. In the late 1950s and early 1960s, governments were learning how to track artificial objects in orbit. Radar stations, telescopes, military reports, launch records, and newspaper stories all overlapped in messy ways. A satellite might be secret. A rocket body might be misidentified. A piece of debris might be seen before anyone had attached a comfortable name to it. Operators worked with plotting boards, grease pencils, teletype paper, and screens that did not explain themselves. The sky had become a traffic lane, but the maps were still being drawn. This is where the Black Knight becomes less like a single object and more like a filing problem. Reports of unknown satellites, unusual orbital paths, and unexplained objects were sometimes gathered under one dramatic label. Yet when researchers try to pin the story down, it tends to shift. One account points to radio echoes, another points to a newspaper report, another points to a photograph. Another adds the alien origin, the ancient age, or the idea of a deliberate polar orbit watching Earth. The object is always just around the corner of the record. Then, there are the famous photographs from the space shuttle era, especially images from a 1998 mission connected with early work on the International Space Station. In some of those images, a dark, irregular object drifts against Earth. It looks strange, almost sculptural. Black folds, pale edges, a shape that seems too crumpled to be a machine and too purposeful to be trash. Many Black Knight articles use these images as visual proof. NASA's explanation is much less theatrical. The object is generally identified as a thermal blanket or piece of insulation lost during the mission. A thermal blanket in orbit is not glamorous, but it is wonderfully specific. Spacecraft insulation can be made of layered materials, thin films, metallic coatings, fabric-like sheets, and fasteners meant to survive vacuum, sunlight, shadow, and cold. If a piece comes loose, it does not fall like a drop towel in a living room. It drifts. It tumbles. Sunlight catches it along an edge, then leaves the rest black. Against the blue curve of Earth, even a discarded blanket can look like an artifact from a civilization with very strong opinions about geometry. My small practical judgment is that space debris is already strange enough without needing much help. A glove, a bolt, a lens cap, a foil panel, a rocket stage. All of these can become temporary moons. They move according to gravity and velocity, not according to the stories we build around them. But the human eye does not like an unexplained silhouette. It wants a category: bird, aircraft, satellite, blanket, visitor, something. The Black Knight legend survives partly because it sits at a pleasant distance from proof, too far away to inspect, close enough to imagine. That is a powerful location for a story. Earth orbit is not deep space, but it is not part of ordinary ground life either. It is a middle zone of weather satellites, spent boosters, classified objects, tumbling debris, and instruments circling in disciplined silence. We depend on that zone for navigation, forecasting, communications, military awareness, and the small miracle of seeing a street map update in a pocket. At the same time, most of us never see the machinery directly. We see its effects. A reflective uncertainty belongs here. We cannot know every emotion behind every sighting, every report, every retelling. Some witnesses may have seen misidentified objects. Some writers may have combined stories carelessly. Some details may have been exaggerated because the stranger version was easier to remember. The evidence does not confirm an ancient alien satellite. It points instead toward a blend of radio anomalies, Cold War tracking uncertainty, speculative interpretation, and misread images. But the record is uneven. Some accounts simply stop there, with an odd note in the margin. What makes this useful to remember now is not that the Black Knight is likely real, as described. It is that modern people live under an increasingly crowded sky and still experience it as mysterious. We have catalogues of orbital debris, radar networks, public satellite trackers, and high-resolution cameras. Yet one dark object in the wrong photograph can still feel like a messenger. The old impulse has not gone away. We keep making watchers out of things above us. There is a soft irony in the name, too. Black Knight sounds medieval, armored, deliberate, almost courtly. But much of the supposed evidence is modern and untidy. Radio static, blurred images, secretive bureaucracies, misplaced insulation, and the technical clutter of entering space before we fully learned how to keep it clean. The romance and the mess share the same orbit, and perhaps that is why the story continues to circle. Not because it has been proven, but because it behaves like the thing it describes. It appears, disappears, returns in altered form, catches a little light, and becomes dark again. A satellite needs velocity to stay aloft. A legend needs repetition. Both are always falling and always missing the ground. From this watcher above the atmosphere, the next strange idea turns inward, away from orbit, and down into the old dream of hidden worlds beneath our feet. This chapter focuses on Hollow Earth, theories of inner worlds. Hollow Earth. Theories of inner worlds is, what if there were entire civilizations beneath our feet? It existed because legends of subterranean peoples and lost cities. The useful thing is to understand the ordinary pressure underneath it before the details start to pile up. Now, Hollow Earth. Theories of inner worlds. Hollow Earth is the idea that our planet is not solid all the way through, but contains vast inner spaces, sometimes imagined as oceans, suns, forests, and civilizations beneath the crust. The theory gave people a way to place the unknown somewhere very close, under the floorboards, rather than across the stars. It turned the Earth itself into a hiding place, which is perhaps why it has lasted so stubbornly in maps, novels, occult writings, and late-night speculation. In its simplest alien version, Hollow Earth asks whether non-human beings might not arrive from the sky at all. They might already be below, in chambers, tunnels, polar openings, or regions of the planet that ordinary maps cannot reach. It touches the hidden neighbor idea from earlier, but here the object is grander. Not a secret base or a cave system, but the Earth as a kind of nested house. The scientific answer is plain enough. There is no good geological evidence that Earth is hollow. Seismic waves from earthquakes pass through the planet in patterns that reveal layers: crust, mantle, outer core, inner core. The details are complicated, but the basic diagram is not. A shock enters the planet, bends and slows through hot rock and metal, and arrives at instruments far away. A seismograph needle scratches its little record onto paper, or now into a digital file, and the shape of that signal tells geologists what the wave moved through. Empty caverns the size of continents would leave enormous signatures. They do not appear. Still, the old theory has an interesting pedigree. In the late 17th century, Edmund Halley, better known for the comet that bears his name, suggested that Earth might be made of concentric shells. He was not trying to write a fantasy novel. He was wrestling with magnetic compass readings, which behaved in ways that seemed puzzling at the time. A hollow or layered Earth, with inner shells rotating differently, offered one possible explanation. It was wrong, as far as the evidence now shows, but it was not merely silly in its own moment. That is a useful thing to remember. Some strange ideas begin as practical attempts to explain a needle that will not point quite where expected. Later versions became more extravagant. In the 19th century, John Cleves Simmes Jr. promoted the idea of a hollow Earth with openings at the poles. He imagined habitable inner surfaces, accessible through vast circular gaps in the Arctic and Antarctic. Simmes even tried to gather support for an expedition. I have a soft spot for the logistical absurdity of that part. Before satellites, before aircraft that could casually cross polar regions, someone still had to think about boots, sledges, ship timbers, salted food, wet wool, frostbite, and money. A theory may be cosmic, but an expedition always comes down to barrels, rope, and uncomfortable socks. Polar openings became one of the most persistent images. On old speculative diagrams, the planet sometimes appears sliced open like fruit, with a little interior sun glowing in the center. The drawing has a strange tidiness to it. Crust as shell, inner world as garden, central light like a lamp in a cellar. It is not how planets work, but as an image, it is oddly satisfying. A place above, a place below, a secret horizon folded inward. Fiction helped carry the idea forward. Jules Verne's Journey to the Center of the Earth did not exactly describe a modern hollow Earth civilization, but it gave readers a route downward. Mineral collections, coded messages, Icelandic volcanoes, dark passages, and the smell of wet stone. Later, adventure stories and pulp magazines imagined inner kingdoms, lost races, underground machines, and sometimes beings who were alien without being extraterrestrial. They were other, but they were not from another planet. They were from a different layer of this one. Occult and esoteric writers also drew subterranean worlds into their systems. Names such as Agartha and Shambhala have been used in modern Western speculation about hidden inner realms, though it is important to be careful here. Shambhala, for example, has a specific and complex place in Tibetan Buddhist traditions, and it should not be flattened into a simple UFO map. Later writers often borrowed names from living religious and cultural contexts, then rearranged them into theories about tunnels and masters beneath mountains. The result tells us as much about modern imagination as it does about the traditions being borrowed from. The legends themselves vary widely. Many cultures have stories of underworlds, caves, ancestral places, mines, buried cities, or realms under hills. Some are sacred geographies. Some are moral landscapes. Some belong to ritual, poetry, or local memory. Hollow Earth believers sometimes gather these stories together as if they were all reports of the same hidden civilization. That move is tempting, but a little too neat. Similar shapes in story do not always mean a single event. People everywhere know the ground opens. Caves breathe cold air. Springs emerge from rock. Mines descend into heat and dust. The underworld is not an abstract idea. If your village has a limestone cave at the edge of the field, with water ticking from stalactites, and a darkness that makes every footstep sound borrowed. What I find interesting is not that Hollow Earth is scientifically persuasive. It is not. The interesting part is how the theory uses closeness. Distant aliens make us look up. Hollow Earth beings make us look down. They change the emotional angle. The mystery is not out past Neptune. It is under the kitchen tile, under the subway tunnel, under the bedrock below a city where plumbers, surveyors, and utility workers are already tracing smaller hidden systems with chalk marks and steel covers. Modern geology has made the inner planet stranger than most Hollow Earth diagrams, in its own way. Not hollow, but dynamic. Plates drift. Mantle rock flows slowly under pressure. Iron in the core helps generate the magnetic field. Diamonds rise from deep volcanic pipes. Ocean crust is born at mid-ocean ridges and disappears into trenches. This is a more difficult picture than a habitable shell. Less cozy, perhaps, but more powerful. The planet is not an empty room. It is a hot, dense engine with a thin, living skin. The sensory reality of going underground is enough to explain part of the appeal. A mine elevator drops and the air changes. The metal cage shivers. Voices become flatter. Dust sticks to the tongue. In a deep cave, the temperature steadies, and the surface weather disappears so completely that rain, noon, and traffic begin to feel like rumors. A person standing there can understand, without much persuasion, why stories collect underground. The body knows it has crossed a boundary. Of course, actual caverns have limits. Limestone dissolves. Lava tubes form. Salt mines spread into orderly corridors. Cities build sewers, bunkers, subways, wine cellars, data vaults, and military facilities. These spaces can be extensive, but they are not a second planet. Rock has weight. Pressure increases with depth. Heat becomes a serious problem. Air, water, food, waste, and structural support are not decorative details. They are the difference between a survivable chamber and a crushed void. The practical side is unromantic and therefore useful. In alien theory, Hollow Earth survives because it offers a compromise between mythology and science fiction. It keeps the ancient feeling of the underworld while adding machines, aircraft, energy sources, and hidden intelligence. Instead of fairies under the hill, the story becomes advanced beings below the crust. Instead of a sacred cave, it becomes an entrance. The costume changes, as it often does. The basic shape remains. There is another people nearby, and we have not been invited in. Perhaps that is the emotional core of it. Human beings live on surfaces. We walk on floors, roads, maps, skin, pages. We rarely see the supporting layers directly. Pipes knock in walls. Trains move beneath streets. Roots search through soil. Even a drawer in an old desk can feel like a tiny underworld if it contains enough receipts, keys, and forgotten screws. The hollow earth theory enlarges that ordinary feeling until the whole planet becomes a piece of furniture with a secret compartment. The evidence points away from a literal inner civilization. Still, the image remains useful as a dream of layered reality. It asks whether the world we know is only the outer face of something deeper, whether our maps are complete, and whether discovery always has to mean distance. Sometimes the unknown is imagined not as far away but beneath, waiting in the dark pressure of the familiar. And with that, the story of inner worlds begins to turn toward a different kind of hiddenness, not a civilization under stone, but a suspicion that power itself might wear a mask. This chapter focuses on the reptilian elite theory. In plain terms, the reptilian elite theory is the claim that shape-shifting reptilian beings secretly control governments, banks, media, and royal families. It gives a simple face to complicated power, turning tax codes, closed meetings, old money, and televised speeches into one hidden species with one hidden plan. For some people, that explanation seems to reduce confusion, even if the evidence for it is not there. A useful image for this theory is not a flying saucer, but a chessboard. Polished wood, felt pads under the pieces, a king with a carved crown, a bishop with a narrow slit, a knight with a horse's head that always looks slightly surprised. In some versions of the story, the pieces are not symbols of power at all. They are disguises. The suit, the title, the television smile, the palace balcony, the conference table with little microphones and sweating water glasses, all become masks. The odd thing is that reptile imagery is much older than modern alien culture. Serpents, dragons, crocodile-headed beings, feathered snakes, underworld monsters, and guardian reptiles appear in many historical traditions. though they mean very different things in different places. Sometimes the serpent is wisdom, sometimes danger, sometimes renewal because it sheds its skin, sometimes chaos, or healing, or royal power. It would be careless to flatten all of that into one modern conspiracy. A carved snake on a temple wall is not evidence of alien rulers. Often, it is just a symbol, and symbols have their own local weather. The modern reptilian elite idea is usually associated with the British writer and speaker David Icke, who became one of its best-known promoters in the late 20th century. His claims spread through books, lecture tours, late-night radio, television interviews, DVDs, and then, very efficiently, through the internet. The internet mattered here. A photocopied pamphlet once had to sit on a folding table at the back of a rented hall. A VHS tape had to be mailed in a padded envelope. A paperback had to be found on a shelf. Online forums changed the texture of belief. A person could sit at a beige computer, hear the little scratch and chirp of a dial-up modem, and find a whole room of strangers already arranging the same clues. That arrangement is part of the mechanism. A conspiracy theory often begins with mistrust, then gathers pattern. Input: a real discomfort with institutions, secrecy, inequality, corruption, or political theatre. Process: select events that seem to fit. Connect names with arrows. Treat coincidence as signal. Treat denial as confirmation. Output: a story in which confusion becomes design. The limitation is important. A story can feel coherent without being true. With the reptilian elite theory, the proposed evidence is usually not evidence in the scientific sense. It may be a slowed-down video clip where a camera sensor glitches and a politician's eye seems to flicker. It may be an odd facial expression caught between frames. It may be a hand gesture, a family crest, a mythic reptile, a badly compressed image from a television broadcast. Anyone who has paused an old news clip at the wrong moment knows how cruel video can be to the human face. Under fluorescent studio lights with makeup powder, dry eyes, and a camera capturing 30 frames per second, almost anyone can look briefly unreal. I find that practical detail useful. The world does not need shape-shifting lizards to make powerful people seem strange. Power already changes a person's setting. It puts them behind glass, on stages, inside motorcades, under flags, beside polished lecterns, and at tables where no one seems allowed to spill coffee. The distance does some of the alienating work by itself. Still, the theory persists because it answers an emotional problem. Modern systems are large, technical, and hard to picture. A central bank decision may involve inflation, targets, bond markets, employment numbers, and spreadsheets full of decimals. A war may involve treaties, fuel routes, old grudges, defense contractors, satellite maps, and politicians using phrases polished by aides. A media empire may depend on ownership structures, advertising markets, legal departments, and audience habits. These are not satisfying villains. They are filing cabinets with consequences. A reptilian ruler, by contrast, is picturable. Scales under the skin, a slit pupil, cold blood, a forked tongue behind a speech. It makes abstraction into a creature. The comfort is not pleasant, exactly, but it is a kind of comfort. If the world is controlled by monsters, then the chaos has a source. Someone is driving. Someone knows the plan. The frightening possibility, perhaps more ordinary and more difficult, is that many systems are driven by incentives, fear, habit, ambition, and neglect, with no single hand on the wheel. This is where the theory becomes more than merely eccentric. Claims about hidden elites can attach themselves to older prejudices, including harmful accusations against real religious, ethnic, or political groups. The language of secret bloodlines, global control, disguised identity, and corrupting influence has a long and ugly history in conspiracy culture. Not every person repeating a reptilian story understands that history, but the pattern is there. A strange alien costume can be placed over very human suspicion. So the calm, skeptical position is not just "there is no proof," though that is true enough. It is also that the story can train the eye to misread people. Once someone expects scales, every shadow becomes scale-shaped. Once someone expects a hidden species, ordinary awkwardness can look like a mask slipping. A tired official blinking under studio lamps becomes a clue. A family resemblance becomes bloodline evidence. A symbol on a seal becomes a confession. Perception, once given a strong enough script, begins to perform. What we cannot know with precision is why every individual finds the idea compelling. Some may be drawn by science fiction, some by distrust after real scandals, some by the pleasure of secret knowledge, some by loneliness, or by the strange companionship of a forum thread moving through the night. The record of belief is usually made of screenshots, interviews, book sales, conference clips, and personal stories, and those materials do not always reveal the private reason a person leaned closer. There is a small philosophical ache inside this topic. Human beings often ask power to show its true face. We want the mask removed, the curtain lifted, the hidden room opened. But sometimes the face behind power is not dramatic. It is tired. It is managerial. It is a person in an expensive suit reading a briefing folder, while someone else adjusts a lapel microphone and a paper cup of water goes lukewarm on the table. That does not make power harmless. It may make it more unsettling because it is not alien enough to excuse us from understanding it. The reptilian elite theory, then, is less useful as a map of reality than as a map of suspicion. It shows how easily mythic images can migrate into politics. It shows how old symbols can be refitted with new machinery. Broadcast cameras, online video compression, message boards, airport bookshops, podcast microphones, and conference center carpets patterned to hide stains. It also shows a basic trade-off in the human mind. A vivid, false pattern may feel better than a dull, true complexity. And perhaps that is the part to carry forward softly. Not the scales, not the secret throne room, not the imagined royal bloodline, but the way a story can change the temperature of a room. A chess piece is only wood until the game begins. A glance is only a glance until someone names it a signal. Some accounts simply stop there, with a paused frame, a red circle drawn around an eye, and a theory waiting in the dark. From hidden rulers, the next strange turn moves toward a different kind of map. Not a palace or a boardroom, but a patch of ocean where ordinary instruments, weather, and rumor have long tangled together. This chapter focuses on the Bermuda Triangle. The Bermuda Triangle is a loose region of ocean often drawn between Florida, Bermuda, and Puerto Rico, where ships and aircraft have been said to vanish or behave strangely. For many people, it became a way to gather scattered maritime accidents into one memorable shape on a map. It gave uncertainty a border, which is something human beings tend to do when the sea refuses to explain itself. The odd thing is that the triangle is not a natural feature. No reef outlines it. No current traces its three sides in foam. It is a shape made by pens, magazine illustrations, book covers, and later television graphics. Still, once you have seen it drawn on a nautical chart, with Miami at one corner, Bermuda far out in the Atlantic, and Puerto Rico down in the warm blue below, it has a certain stubborn power. A triangle feels intentional. It looks less like geography and more like a warning label. On a desk, the old version of the mystery belongs to paper. A crumpled nautical chart, maybe with pencil marks, compass roses, depth numbers, and little wrinkles where someone folded it badly in a cockpit or cabin. A ruler slides from point to point. The sea, reduced to pale blue ink, looks manageable. That is one of the quiet ironies of navigation. The map is flat, clean, and dry. The actual ocean is moving under clouds, with salt on the windows and a radio voice half buried in static. Some of the famous cases connected to the Bermuda Triangle involved ordinary difficulties made frightening by distance. Aircraft navigating over open water can lose visual reference. Ships crossing busy lanes can meet storms, mechanical trouble, or human error. The Gulf Stream moves like a broad, invisible conveyor belt, carrying debris away from where someone might expect to find it. A small object dropped into that current may not stay politely near the last known position. That detail matters. Searchers do not look for a mystery in the abstract. They look for oil slicks, floating cushions, a broken antenna, a reflection from aluminum, a radio signal, a line of foam where something should not be. A few miles of drift can change a search grid. A cloud deck can erase the horizon. A compass reading can be misread by a tired person trying to do 3 tasks at once. I find that practical side more unsettling than some of the grander theories because it reminds us how thin the margin can be. Then there is Bruce Gernon's account from 1970, one of the stranger stories attached to the region. Gernon, a pilot, later described flying through an unusual cloud formation while traveling near the Bahamas. In his telling, the clouds seemed to form a kind of tunnel. He reported strange visual effects, unusual instrument behavior, and an arrival that seemed too quick for the distance covered. The story has often been called a time warp experience, though that phrase does a lot of imaginative work. What can be said carefully is this. Gernon's account became one of the clearest examples of the Bermuda Triangle shifting from a disappearance legend into a space and time legend. Earlier stories often asked, where did the vessel go? This one asked, what happened to distance itself? That is a different kind of mystery. It does not merely remove an object from the map. It bends the map. at least in the imagination. Aviation has its own eerie vocabulary for confusion, spatial disorientation, instrument error, cloud tunnel, electrical disturbance. A pilot inside cloud may lose the ordinary agreement between eye, hand, and inner ear. The body can insist that the aircraft is level when it is turning, or climbing when it is not. Instruments are meant to correct this, but instruments require trust, training, maintenance, and calm interpretation. A panel of dials, metal switches, and trembling needles is a small democracy under pressure. If this helps you rest, you can always come back to it another night. If this helped the room feel softer, you can save it and return later. Several natural explanations have been suggested for Bermuda Triangle stories, and none of them needs to be theatrical to be interesting. Magnetic variation is one. A compass points toward magnetic north, not always true north, and the difference changes depending on location and time. Navigators know this and correct for it, but popular accounts have sometimes treated compass behavior as stranger than it is. Still, a bad correction, an old chart, or a distracted calculation can matter when water covers every landmark. Weather is another plain but powerful explanation. The region can produce sudden squalls, thunderstorms, waterspouts, and rough seas that rise with very little patience for schedules. Warm tropical air, shifting pressure, and open water can turn a manageable crossing into a confusing one. Radar helps. Forecasts help. But weather is not a wall on a map. It is a process, and processes do not always wait for people to understand them. Methane has also appeared in theories about vanishing ships. The basic idea is simple enough. Gas released from the seafloor could, in theory, rise through water and reduce its density, making a vessel less buoyant. Input: gas bubbles. Process: disturbed water. Output: possible loss of flotation. Limitation: evidence for this as a major explanation in the Bermuda Triangle is weak, and the conditions would have to be quite specific. It is a tidy mechanism, perhaps too tidy, which is often the case with explanations that become popular after the fact. And then, layered over these possibilities, come the alien theories. Some versions imagine underwater bases beneath the Atlantic. Others suggest portals, gravity anomalies, or craft using the region as a passageway. These ideas do not have solid evidence behind them, but they reveal something about the emotional shape of the Bermuda Triangle. The sea already hides things. It covers wreckage. It muffles sound. It turns distance into a kind of veil. If a person is already wondering where an advanced intelligence might conceal itself, deep water is an efficient answer. What makes the triangle useful to remember now is not that it proves anything extraterrestrial. It does not. The evidence points much more strongly toward weather, navigation, currents, human error, mechanical problems, and the way stories grow when details are missing. But the alien layer shows how quickly a gap can become a doorway. A missing radio call becomes a signal interrupted by forces unknown. A late arrival becomes lost time. A cloud becomes a tunnel. A patch of ocean becomes a machine. There is a small philosophical drift here, and it belongs to the subject. The Bermuda Triangle is partly about the discomfort of incomplete records. Ships depart. Aircraft check in. Logs are written in pencil or typed on forms. Then, at some point, the record thins. A final position, a weather note, a search report. Some accounts simply stop there. The mind dislikes that kind of ending. It reaches for structure. And sometimes it reaches all the way to aliens. Because aliens at least give the silence an author. My own preference, for what it is worth, is to start with the boring tools. The compass, the radio, the barometer, the fuel gauge, the maintenance log, the weather report with coffee rings on it. They are not glamorous, but they are honest. They remind us that most mysteries happen inside systems that were already complicated before the strange part began. A pilot is not just flying through legend. He is checking headings, watching cloud tops, listening for instructions, and trying to keep the aircraft where the chart says it should be. The Bermuda Triangle remains mind-bending because it sits at the meeting point of three things: a real ocean, imperfect records, and a human talent for pattern. Its alien theories are one layer among many, like pencil marks added over older pencil marks on a chart. Some marks may help, some may mislead. All of them show the same urge to make the blank water speak. From this watery triangle, the next mystery moves inland, to a forest of pines, military gates, and lights seen between the trees. This chapter focuses on the Rendlesham Forest Incident. The Rendlesham Forest Incident is a series of reported sightings of unexplained lights and physical traces near military bases in Suffolk, England, in December 1980. It matters because the witnesses were not only casual passers-by, but military personnel trained to notice, report, and follow procedure. For people interested in alien theories, it became one of those rare cases where the strange thing in the trees also left paperwork behind. The setting was Rendlesham Forest, a planted pine forest near RAF Woodbridge and RAF Bentwaters, which at the time were used by the United States Air Force. This was not a remote ruin or a lonely hilltop with nothing nearby. It was a working military landscape with gates, patrol routes, radios, vehicles, perimeter lights, muddy tracks, and people awake at hours when most villages had gone dark. That practical detail matters. A forest beside an airbase is already a place where ordinary lights can become complicated. In late December, around Christmas, several personnel reported seeing strange lights beyond the base perimeter. Some accounts describe red, blue, or white lights moving among the trees. Others mention a glowing object, or something that seemed to land, or lights that appeared to shift in ways that were difficult to match with familiar aircraft. The air would have been cold, and the forest floor damp underfoot, with pine needles, bracken, and sandy soil. Even before any theory enters the room, it is useful to remember the physical discomfort of the scene. Boots in wet ground, breath in the dark, radio chatter, not quite keeping up with what the eyes think they see. The first reported episode involved security personnel going out to investigate what they believed might be a downed aircraft or some kind of intrusion. That is a sensible reaction, not a theatrical one. If unexplained lights appear near a military installation, someone has to go and look. A patrol does not get to shrug and make tea, though I suspect tea would have been the better evening. They moved into the forest and later described seeing unusual light, and in some versions, a small craft-like object. The details vary depending on the account, which is not unusual in reports formed under stress, darkness, and expectation. What makes the case linger is that the story did not end with one sighting. Later, Deputy Base Commander Lieutenant Colonel Charles Holt went into the forest with others to examine the area. Holt made an official memorandum afterward, often called the Holt Memo, and also recorded an audio tape during part of the investigation. These are not proof of aliens, but they are solid artifacts of confusion. Paper has its own peculiar authority. A typed memo, with dates and ranks and measured language, makes even uncertainty feel heavier on the desk. Personnel reported marks on the ground, sometimes described as triangular impressions, as well as damage or markings on trees. Radiation readings were reportedly taken, though the meaning of those readings has been debated. A skeptic can fairly ask whether the readings were unusual, whether the equipment was used properly, and whether the reported marks might have had ordinary causes. Still, the presence of measurements changes the atmosphere of the story. Somebody brought a device. Somebody bent down in the needles and mud. Somebody tried to turn an uncanny night into numbers. The odd thing is that good procedure can preserve mystery as easily as it resolves it. A witness writes down what he saw, and now the uncertainty has a file number. A tape recorder captures calm voices describing lights in the distance, and now the darkness has a soundtrack. The method is rational, almost boring, and yet the result remains strange. That is why Rendlesham has survived while many other UFO stories have drifted away. It has just enough official texture to keep the mind from putting it down. If you're still up and listening, feel free to like and subscribe. Topic requests are welcome below. Several explanations have been proposed over the years. One possibility is misperception. Bright stars, aircraft, vehicle lights, and the beam from the Orford Ness Lighthouse have all been suggested as contributors. A lighthouse is a beautifully ordinary suspect, mechanical, repetitive, indifferent. It sweeps its beam across the night because that is what it was built to do, warning sailors from a fixed point, not trying to frighten airmen in a pine forest. Under the right conditions, through trees and mist and distance, a repeated light can seem to move, vanish, and return. Another explanation involves astronomical events, such as a meteor or fireball, which may have been seen around the same period. A meteor can look startlingly close when it burns through the upper atmosphere, especially if the observer has no clear horizon and is already alert for trouble. The input is simple enough. A bright object crosses the sky. The process is human perception under stress, in darkness, near a military base. The output can be a report of something descending nearby. The limitation is equally simple. Afterward, the brain wants edges, distances, and intentions where there may have been only light. Hoax theories have also appeared, though they tend to explain some parts better than others. Forests near bases attract stories, jokes, local knowledge, and occasional mischief. A prank could create lights or misleading impressions, but it is harder to make a prank account for every witness, every later recollection, and the official follow-up. That does not make the extraordinary explanation correct. It only means the ordinary explanation has to do careful work too. I find this a useful rule in these cases. Skepticism should be as precise as belief. A vague dismissal is not much better than a vague marvel. Then there is the alien interpretation, the one that made Rendlesham famous. In that version, the lights were connected to a non-human craft, perhaps landed briefly in the forest before leaving traces behind. Some later accounts became more elaborate, adding details that are difficult to verify, and sometimes disagreeing with earlier records. This happens often with famous events. Memory is not a filing cabinet. It is more like soft wax handled over many years, warmed by interviews, documentaries, arguments, and the strange pressure of being asked again and again what really happened. What we cannot know with certainty is what each person saw in the exact moment before language touched it. The forest did not write a report. The pines held their needles. The sandy soil took impressions from whatever pressed into it, and the cold air carried lights from distant places. Some evidence points toward misidentified natural or human-made sources. Some witness statements continue to resist a simple explanation. The record contains both discipline and drift, and that combination is why the case remains so difficult to close neatly. There is a small philosophical unease here, but it is not the loud kind. Rendlesham asks what happens when trained observers meet something ambiguous. We like to imagine that discipline protects us from mystery, as if a uniform, a radio, and a clipboard can keep the world inside its proper categories. Often they do help, but sometimes they only give uncertainty a sharper outline. The more careful the witness, the more interesting the unresolved part becomes. For alien theory, Rendlesham occupies a specific little shelf. It is not mainly about grand cosmic silence, or hidden civilizations, or ancient symbols in stone. It is about an encounter at ground level. Men in uniform, winter pines, perimeter security, a tape recorder, and lights that would not settle into an agreed explanation. That is its particular shape. The mind-bending part is not that it proves visitors came from elsewhere. It is that ordinary systems of observation briefly failed to make the night ordinary again. By morning, the forest would have looked less dramatic. Pine trunks, rutted tracks, damp soil, perhaps a few marks being pointed out by tired men who had been awake too long. Daylight is sometimes rude that way. It takes the silver edge off things. Yet the reports remained, and the story kept moving from office desks to newspapers to books to late-night conversations. Rendlesham Forest, in the end, is a quiet witness rather than a witness that speaks. It offered lights, marks, distances, and confusion. People supplied the rest: caution, fear, wonder, skepticism, memory, and somewhere between the trees and the paperwork, the incident became one of the most persistent modern stories of a possible encounter, still dimly visible, like a pale beam passing again between the pines. This chapter focuses on wormholes and UAPs. A wormhole is a hypothetical shortcut through space-time, a kind of tunnel that would connect two distant regions of the universe. The idea exists because ordinary travel across cosmic distances is painfully slow, even for light, and wormholes offer a mathematical way to ask whether distance itself might be folded rather than crossed. For UFO and UAP stories, that possibility has an obvious appeal. It gives a speculative shape to sudden arrivals, sharp disappearances, and motion that seems to ignore ordinary limits. A useful object here is a smooth stone with a natural hole through it, the sort you might find on a beach, and keep for no very good reason. Place it on a stack of physics books, and it becomes a small, humble model. Not accurate exactly, but helpful. Instead of walking around the stone, a thread can pass straight through the opening, a shortcut, if the world allows such a hole to exist. Physics, unfortunately, is less obliging than a beach stone. In general relativity, space and time are not a fixed stage. They can curve. Massive objects bend them, and light follows that bending. This has been tested in ordinary and extraordinary ways. Starlight shifting near the sun, clocks ticking at slightly different rates depending on height and speed, satellites needing careful corrections so navigation systems do not wander out of usefulness. I find that last detail especially grounding. One of the strangest ideas in modern physics is quietly involved in helping a delivery driver find the correct driveway. Wormholes come from that same flexible picture of space-time. In some solutions to Einstein's equations, two separate regions could be linked by a throat. The input is curved space-time. The process is an extreme geometry, where two distant points are connected by a passage. The output, in theory, is a route shorter than the outside path. The limitation is the difficult part. Keeping such a tunnel open may require exotic conditions, such as negative energy, and no one has shown that a usable, stable, traversable wormhole exists in nature. That is the boundary. It is not a small boundary. Still, the idea keeps returning because it solves a story problem as much as a physics problem. If something appears in the sky, moves in a way that seems abrupt, and then vanishes, the human mind looks for a doorway. We know how doors work. We understand thresholds. A door makes an impossible change feel domestic. Before the door, the hallway. After the door, another room. In UAP discussions, wormholes are sometimes suggested as one possible explanation for reports where an object seems to appear or disappear rapidly. The best-known modern case often mentioned near this kind of speculation is the 2004 incident involving the USS Princeton and associated Navy personnel off the coast of Southern California. Reports described unusual radar tracks and an object observed during the broader encounter, sometimes called the Tic Tac because of its plain white oblong shape. The accounts have been debated, examined, retold, and folded into later public discussion about unidentified aerial phenomena. What matters for this chapter is not to prove what that object was. The evidence does not let us do that cleanly. Radar systems can misread. Human observation has limits. Instrument records can be incomplete, classified, degraded, or interpreted in more than one way. But the reported behavior, especially the sense of rapid appearance, relocation, or disappearance, makes people reach for physics at the edge of imagination. A radar room is a good place to understand the tension. Not a dramatic one, just a working space. Metal consoles, dark screens, a faint electrical smell, coffee cooling in a paper cup, someone watching green or pale markings shift against a grid. A radar return is not an object held in the hand. It is a signal interpreted by a machine, then by a human being. The machine receives energy back from the world. The operator receives a pattern. Between the two, there is room for weather, calibration, software, reflection, training, expectation, and occasionally something that does not fit well. That gap is where wormholes become tempting. If a craft could use a wormhole, at least in science fiction terms, it would not need to accelerate across every mile between here and there. It might enter a region of altered geometry and exit somewhere else. To an outside observer, the object might seem to vanish from one place and reappear in another without the long passage in between. No blazing engine, no long arc, no patience. The odd thing is that this explanation is both extravagant and neat. Extravagant because it asks for technology beyond anything we know how to build, and possibly beyond what the universe permits in a practical form. Neat because it turns messy observation into a clean diagram. Object enters tunnel. Space-time carries the shortcut. Object exits elsewhere. I am fond of clean diagrams, but I distrust them a little. They sweep the dust off the table too quickly. A real traversable wormhole, if such a thing could exist, would not merely be a hole in space. It would need structure. It would need stability. It would need to avoid collapsing faster than anything could pass through. It might create intense gravitational effects near its throat. Depending on the model, it might distort light, time, and tidal forces in ways that would not be subtle. A person could draw it with a pencil in 10 seconds. 2 dots on paper, a folded sheet, a pencil pushed through. Nature would be less casual about the paperwork. And yet, the folded paper demonstration remains powerful. Put 2 dots on opposite ends of a page. Traveling across the flat sheet takes the long way. Fold the page until the dots touch, and suddenly, the distance is changed by changing the geometry. It is a childlike demonstration, usually done with printer paper or a napkin, and it is almost too satisfying. The crease does all the persuasion. You can hear the paper fibers complain softly as it bends. That little sound is a reminder. Models are tools, not proof. The philosophical drift, if we allow it for a moment, is that wormholes express an old wish in a modern accent. We dislike the tyranny of distance. We make bridges over rivers, tunnels through mountains, canals across narrow strips of land, radio signals across oceans, fiber optic cables under black water. We keep making shortcuts. And then we imagine the largest shortcut possible. One not through rock or sea, but through the arrangement of reality itself. The alien part of the theory may be less strange than the shortcut part. Wanting a hidden passage is very familiar. This is why UAP stories and wormholes fit together so easily in the public imagination. UAPs, by definition, are things not yet identified in a given account or data set. Wormholes are not identified objects either. They are theoretical structures permitted in some mathematical context, but not observed as working cosmic tunnels. Put them together, and you get 2 unknowns making a shape that feels almost explanatory. But 2 unknowns do not equal 1 known. That is a small, practical truth worth keeping nearby, like a bookmark in a difficult chapter. Some physicists have also considered whether wormholes, if they existed, might leave traces. Gravitational lensing patterns, strange distortions of background light, or other signatures in astronomical data. These would be subtle, technical matters, not a glowing doorway opening above a field. A telescope, a spectrum, a statistical anomaly in a survey. That is more likely how the first hint would arrive, if it arrived at all. Not with a trumpet, more like a line in a data set that makes someone frown and check the equipment twice. That, to me, is where the subject becomes most interesting. The popular image is sudden and cinematic. A craft dropping through a cosmic seam. The scientific search, if it ever becomes relevant, would probably be slow, dusty, and procedural. Someone would adjust an instrument. Someone would compare models. Someone would argue over whether the signal was noise. The universe, when it reveals anything, often makes people fill out forms first. So when wormholes are used to explain UAPs, it is best to hold the idea lightly. It may be a useful imaginative frame for why some reports feel so impossible. It is not evidence by itself. The 2004 Navy accounts remain important because they involve trained observers and military sensor systems. But even those details do not turn a speculative space-time tunnel into a demonstrated mechanism. The record suggests something unusual was reported. What it was remains unsettled. Still, there is a certain beauty in the boundary. Physics says, here are equations that allow astonishing geometries. Observation says, here are events that do not yet sit comfortably in our categories. Caution says, do not weld the two together too soon. Imagination says, but notice how the shapes almost meet. And perhaps that is enough for this part of the night. A holed stone on a stack of books, a radar screen in a metal room, a folded sheet of paper with 2 pencil dots pressed together. Not proof of visitors, not a doorway we can point to. Just a reminder that even our limits have architecture, and sometimes the mind stands at the edge of them, listening for the faint sound of paper bending. This chapter focuses on panspermia. Panspermia is the idea that life, or the raw ingredients for life, can travel between worlds and take root somewhere new. It exists as a way to think about one stubborn problem. Life appeared on Earth very early, and we still do not fully know how non-living chemistry became biology. Instead of asking only how life began here, panspermia asks whether life may also move, like dust, pollen, or seeds carried across a very large dark field. The word itself has an oddly domestic feeling, considering the scale of it. Seeds everywhere. Seeds scattered wide. A small dish of pollen beside a microscope would not look especially cosmic at first glance. Just yellow grains, faintly powdery, clinging to glass and tweezers. The sort of thing that gets on a sleeve and refuses to leave. But panspermia borrows that image and enlarges it until the field is not a meadow, but the solar system. In one version, a rock is blasted from a planet by an impact. Not neatly, not gently, but efficiently enough. A meteorite strikes Mars, for example, and throws pieces of crust upward with such force that some escape the planet's gravity. Inside a pocket of stone, perhaps shielded by minerals, ice, or tiny cracks, microbes or organic molecules may be carried into space. The rock drifts for thousands or millions of years. Eventually, it falls onto another world, arriving as a meteorite with a blackened fusion crust, a cold interior, and a history written in minerals. The mechanism is not mystical. Input a living microbe, spore, or chemical precursor inside rock. Process: violent ejection, long exposure to vacuum and radiation, then fiery entry through an atmosphere. Output: a possible delivery of biological material to a new surface. Limitation: nearly every step is difficult, and difficulty matters. A theory can be elegant and still have to pass through heat, shock, ultraviolet light, cosmic rays, and time. What makes panspermia worth taking seriously, at least as a possibility, is that some forms of life are annoyingly durable. I say annoyingly with admiration. Anyone who has tried to keep a clean kitchen sponge for more than a week understands, in a very small way, that microbes have their own opinions about hardship. Certain bacterial spores can survive drying, freezing, and radiation far better than a soft-bodied creature could. Deinococcus radiodurans, often mentioned in this context, is famous for tolerating radiation damage. Bacillus spores can enter dormant states, becoming more like sealed packages than active cells. Laboratory experiments have placed microbes, spores, and hardy organisms under conditions meant to imitate parts of space. Vacuum chambers, ultraviolet lamps, freezing temperatures, and desiccation. Some have also been exposed outside spacecraft or on platforms attached to the International Space Station. These studies do not show that life definitely traveled from Mars to Earth or from another star system to ours. That would be too tidy. They show something narrower and more interesting. Biology is not always as fragile as our own bodies lead us to assume. A human hand goes numb in cold wind. Skin cracks. Breath clouds. We are not good models for all life. Some organisms can wait. That waiting is one of the strange emotional centers of panspermia. A dormant spore is not exploring in any heroic sense. It is not steering. It has no little brass compass. It is sealed down into stillness, doing almost nothing, trusting no one. If trust is even the right word for chemistry, slowed to a near pause. What I find interesting is how unromantic the practical version of panspermia is. Not silver ships, not messages, just stone, dust, impact, orbit, and survival by being very small. Meteorites give the idea a physical handle. We know rocks move between planets because meteorites found on Earth have been identified as Martian in origin. Scientists can recognize them by trapped gases and mineral chemistry that match measurements of Mars. These objects are not rumors in the sky. They are stones in cabinets, weighed on balances, cut with diamond saws, studied under microscopes. Some are kept in clean labs, where a technician in gloves handles them with the caution usually reserved for both treasure and evidence. That word, evidence, needs to be kept close. Panspermia has suggestive pieces, but no direct proof that living organisms arrived here from elsewhere. No meteorite has handed over an unambiguous alien microbe. No chain of custody runs from another world to a living cell in an earthly tide pool. Organic molecules have been found in space and in meteorites, including amino acids, which are building blocks used by life as we know it. But building blocks are not buildings. Flour on a counter is not bread. This is a small practical truth, and a useful one. Still, chemistry arriving from space may have mattered. Comets and carbon-rich meteorites could have delivered water, carbon compounds, and other ingredients to the young Earth. In this softer form, sometimes called molecular panspermia, the claim is not that life arrived fully made. It is that the early Earth may have been seeded with useful materials from beyond itself. A planet with oceans, lightning, volcanic vents, clay minerals, and incoming organic-rich debris becomes a kind of workshop. Messy, damp, warm in places, frozen in others, and not especially organized. That version feels less theatrical, but maybe more plausible. A meteorite lands in shallow water. Rain strikes hot stone. Minerals leach out. Carbon compounds mix into a thin film on basalt. No one is present to admire the scene. The only sound is weather, if there is sound at all, and perhaps the hiss of cooling rock. For a sleep essay about aliens, it is almost comically modest. The alien visitor may not be a visitor, but a molecule. Some thinkers have proposed a stronger form called directed panspermia, where an advanced civilization intentionally sends life-bearing material into space. That idea has a science fiction neatness to it, and it raises more questions than it answers. Who sends it? Why? How would they choose the cargo? Would they send microbes, DNA, frozen embryos, or just hardy chemistry? I find myself skeptical of the tidy versions, mostly because intentions are expensive assumptions. Rocks already travel. Dust already drifts. Nature does not need a mission statement to scatter things. But even without purposeful gardeners, the implications are quietly large. If life can move from world to world, then biology is not only a local accident sealed inside one planet, it becomes a bridge. A meteorite is no longer only a scar from collision, but also a possible envelope. A comet is no longer only ice and dust, but perhaps a cold courier of carbon chemistry. The boundary between Earth and elsewhere becomes more porous than it first appears. This does not mean life is common. It does not mean Earth was certainly seeded from Mars, or that Mars was seeded from Earth. Though material exchange between the two planets is physically possible, it does not answer how life began in the first place. That is the old difficulty hiding under the rug. If panspermia moves life from one place to another, it still leaves us asking where the first living system arose. The record may not preserve that answer clearly. Rocks melt, crust recycles, oceans change, and the earliest evidence is faint. The philosophical drift here is simple, and perhaps a little comforting, without trying too hard. If panspermia is even partly true, then life is not quite as isolated as it feels. The microbes in soil, the lichen on stone, the faint green film in a rain barrel, and the cells in our own bodies would belong to a wider material story. Not because aliens built us, necessarily. Not because anyone planned us. But because the ingredients of life may have crossed distances before they ever became familiar. A grain under a microscope can look like a small moon. A bacterial spore can look almost disappointingly plain. Yet plain things have a habit of carrying the real weight of history. The grand theory comes down to whether something tiny can endure a bad trip. Shock, cold, darkness, radiation, entry heat, impact, and then, if it is fortunate, water. The odd thing is that panspermia makes alien life both stranger and less strange. Stranger, because it suggests that life may have traveled through space, hidden inside stone. Less strange, because if such transfer happens, then any life we find nearby might not be wholly separate from us. It could be cousin chemistry, a distant branch from the same scattered stock. Even the word alien softens a little under that possibility. In the next chapter, the focus turns back toward listening, toward the long patience of SETI and the silence around our radio searches. But panspermia leaves us with a different kind of listening first. Not antennas pointed at stars, but microscopes pointed at dust, meteorites, spores, and old carbon. A quieter question, perhaps. Not who is calling, but what has already arrived. This chapter focuses on the silence of SETI. SETI is the search for extraterrestrial intelligence, the careful attempt to detect signs of technology beyond Earth, usually by listening for unusual radio signals. It exists because radio waves can cross enormous distances, and because a signal made on purpose might stand out from the natural hiss of stars, gas, and galaxies. In plain human terms, SETI is a patient habit. Point an instrument at the sky, collect what arrives, and ask whether any of it looks like someone trying to be noticed. The instruments themselves are not mystical objects. They are metal, cable, concrete, coolant, software, and weather. A radio telescope may look like a great white bowl tilted toward the dark, but much of the work happens in racks of electronics, hard drives, filters, clocks, and ordinary chairs with wheels that squeak a little on polished floors. At Green Bank in West Virginia, at parks in Australia, at the Allen Telescope Array in California, the practice has often been less like chasing a flying saucer and more like maintaining a very fussy ear. I find that detail useful. The search for alien intelligence is often imagined as dramatic, but the actual work has a domestic quality, checking logs, ruling out interference, labeling files, making sure a cable has not loosened, making sure the signal is not coming from a passing aircraft, a satellite, a phone tower, or some human machine behaving badly nearby. The basic idea is simple enough to draw on a napkin. A dish gathers faint radio energy from a patch of sky. Receivers turn that energy into electrical signals. Computers break those signals into narrow frequency channels. Looking for something too neat, too concentrated, or too strangely patterned to be natural. The output is not a message at first. It is a candidate, a little mark in the data, a possible thread. Then comes the less glamorous part, which may be the most important part. Researchers try to make the signal appear again. They point away from the target, then back. They compare other telescopes. They check local sources. They ask whether a human transmitter could have wandered through the beam. If the signal does not repeat, or if it follows the telescope in the wrong way, or if it appears at a frequency used by Earth technology, it becomes less interesting. Not worthless, exactly. just less alien. This is where the silence begins to have texture. It is not an empty silence. It is full of rejected candidates, cleaned data, false alarms, and faint natural sources. Space is not mute. Pulsars tick. Jupiter emits radio bursts. The sun crackles. Hydrogen has its famous line near 1420 megahertz, a frequency that has tempted many SETI thinkers because it is tied to a common element and sits in a relatively useful part of the spectrum. But natural noise is not the same thing as a greeting. In 1960, Frank Drake's Project Ozma used a radio telescope at Green Bank to listen to nearby sun-like stars. It was a modest beginning, almost charming by later standards, with limited time, limited bandwidth, and equipment that now feels like it belongs partly to science and partly to a museum of knobs. Since then, searches have become broader, faster, and more automated. Modern surveys can examine huge amounts of spectrum, store enormous datasets, and return to old observations with new algorithms. And still, no confirmed signal. That sentence is easy to make too heavy, so it is worth holding it carefully. No confirmed signal does not mean no one exists. It means no signal has passed the tests we have set, in the places we have looked, at the times we were looking, in the forms we were prepared to recognize. The sky is large in several inconvenient ways at once. It has direction, frequency, time, signal strength, repetition, polarization, and meaning. Searching it is not like checking whether a letter has arrived in the mailbox. It is more like standing beside an ocean at night with a teacup, wondering whether a particular wave contains handwriting. The odd thing is that this limitation does not make SETI less scientific. It may make it more scientific. A weaker version of the search would keep every strange blip and decorate it with wishful thinking. A stronger version spends most of its time saying no. No, that was aircraft radar. No, that was a satellite. No, that was a terrestrial transmitter leaking into the side of the receiver. At Parkes, some mysterious short radio bursts called peritons were eventually linked to microwave ovens being opened before they had finished. I have a soft spot for that kind of discovery, because it is humbling in the right way. Sometimes the universe is not speaking. Sometimes someone is reheating lunch. Still, a few signals have remained memorable because they were strange before they became unresolved. Some were narrow, some were strong. Some appeared once and then vanished. They entered the folklore of the field not as proof, but as reminders of how delicate the rules have to be. A signal that happens only once is difficult to build a claim upon. A signal that repeats too predictably may be earth-made. A signal that carries no recognizable structure may be only noise wearing a temporary mask. This is the central trade-off of SETI. If researchers are too skeptical, they may discard something unusual before understanding it. If they are too eager, they may mistake a refrigerator, a satellite, or a human broadcast for cosmic company. The best work lives in that narrow middle space, where hope is allowed in the room, but not allowed to touch the instruments. There is a philosophical strangeness here that I find quietly moving. SETI is one of the few sciences built around waiting for another mind to choose a compatible form of expression. We are not only measuring rocks or light or chemistry, we are asking whether intelligence elsewhere has used technology in a way that leaks, beams, pulses or sings across space, and we are asking whether our own tools are humble enough to notice. Perhaps the silence says something. Perhaps it says that transmitting loudly is rare. Perhaps advanced societies use methods we do not yet understand, or prefer tight beams that never cross Earth, or communicate through media we are not watching. Perhaps civilizations are separated by time more than distance, one speaking for 1,000 years, another listening 1,000,000 years too late. Or perhaps the nearest life is simple, microbial, patient in its own chemical way, with no towers, no transmitters, no engineers tightening bolts in the cold. What we cannot know, from silence alone, is whether we are alone or merely early, late, distant, unlucky, or using the wrong receiver. That is the difficulty. Absence of evidence can be meaningful, but it is rarely simple. Each year of listening closes some small portion of possibility and leaves the rest open, like a cabinet full of drawers that have not yet been checked. The physical work continues anyway. Dishes turn on steel bearings. Motors make slow corrections against wind. Hydrogen maser clocks keep time with absurd care. Headphones may rest on a desk beside a shortwave receiver, though the real listening is done by software now, not by a person waiting for a voice in static. Screens show waterfalls of color, frequency drifting downward as Earth rotates and the source changes relative motion. A promising line in that display can look very small, almost disappointingly small, considering what people hope it might mean. That is part of the discipline. SETI takes one of the largest questions a person can ask and reduces it to calibration, patience, and statistical caution. It is a grand idea forced to wear sensible shoes. For now, the reply has not come, or if it has, we have not recognized it. The record holds searches, candidates, rejections, upgraded receivers, lost funding, restored programs, better computers, and researchers who keep returning to the sky with a steadiness that is almost tender. Not because they know someone is there, because the question is clean enough to be worth asking again. And after all these stranger theories of hidden visitors, buried neighbors, and minds beyond ordinary space, SETI remains almost plain. It does not begin with a sighting or a legend. It begins with an antenna, a clock, a frequency, and a refusal to pretend that a maybe is more than a maybe. The silence is not an answer in full. It is only the answer we have so far, resting in the data, waiting to be checked once more. This chapter focuses on ancient astronauts, traces in stone and story. Ancient astronaut theory is the idea that beings from beyond Earth visited human societies in the deep past, leaving marks in monuments, myths, carvings, and unusual stories. For some people, it offered a way to connect old wonders with modern space-age imagination. It also solved, perhaps too neatly, a very human problem: how to explain things that seem larger, older, or stranger than our ordinary sense of what people can make. A small stone figurine on a museum shelf can begin the whole argument. Not because it proves anything, but because it asks for interpretation. A rounded head, wide eyes, hands pressed to the body. clay fired hard enough to survive centuries in the ground. Beside it, perhaps, an open book of ancient art, with photographs printed slightly too dark, the paper smelling faintly of dust and glue. Someone looks at the figure and says, "That resembles a helmet." Someone else says, "No, that is a ritual mask, or a stylized face, or simply the local way of shaping a human form in clay." The odd thing is that both people are doing something very human. They are comparing the unknown to the known. One person knows astronauts, pressure suits, visors, oxygen hoses. Another knows burial goods, regional craft styles, pigments, and ceremonial costume. The object itself does not change. Only the frame around it changes. The famous examples tend to arrive in a familiar order. The pyramids of Egypt, with their enormous limestone blocks and careful alignments. The Nazca lines in Peru, with long figures and straight paths scraped into the desert floor. The stonework of places like Baalbek, or the fitted blocks of Andean sites, where seams can be so tight that a knife blade seems to have no business there. A person standing near these works can feel a small bodily disbelief. The sun is hot. The stone is heavy. The ground is uneven. The first thought is not always scholarly. Sometimes it is simply, how did anyone do this without engines? That question deserves respect. It is a good question. A limestone block weighing several tons is not made lighter by confidence. Rope frays, wooden sledges crack, mud dries. Workers need food, water, rest, coordination, and someone keeping count with marks on a board or scraps of cord. My own quiet preference is to start there, with the inconvenience. The practical trouble of moving stone often tells us more than the grand theory placed on top of it. Archaeology usually answers with patient systems rather than visitors from the sky. The Egyptian pyramids point toward quarrying, skilled labor organization, ramps or sledges, copper tools, stone pounders, water, and a bureaucracy capable of feeding crews for long periods. None of that makes the achievement smaller. If anything, it makes it more impressive, because it replaces a single miracle with thousands of repeated tasks. A worker sharpening a copper chisel, a scribe noting grain rations, a mason checking a corner by feel in the morning light. That, to me, is more astonishing than a hidden spacecraft doing the difficult part off stage. The Nazca lines have a different kind of puzzle. They are not built upward, but drawn outward across dry desert ground. The makers remove the darker surface stones to reveal lighter soil beneath, creating lines, animals, spirals, and geometric forms that can stretch across great distances. From a hill or an aircraft, the figures become clearer. That aerial view has encouraged the thought that they were made for beings in the sky. But another explanation is simpler. People on the ground can make very large patterns with stakes, cords, sight lines, and repeated measurements. A long cord pulled taut across dusty earth is not glamorous, but it works. Still, the sky matters. Many historical societies watched the heavens carefully, not because they were primitive astronomers waiting for aliens, but because the heavens were part of agriculture, ritual calendars, navigation, and political authority. The rising of a star, the turning of a solstice, the return of a season. These were practical matters, woven into planting, pilgrimage, and ceremony. A monument aligned with the sun does not need a spaceship to make sense. It needs people who looked up every year and remembered. Some ancient astronaut writers have pointed to myths as another kind of evidence. Stories of beings descending from the heavens. Chariots of fire. Gods teaching agriculture, metalwork, law, writing, or the ordering of cities. In the 20th century, especially after rockets and satellites entered ordinary imagination, some readers began to reinterpret these stories as confused memories of alien contact. The old god becomes a pilot. The shining cloud becomes exhaust. The sacred mountain becomes a landing platform. This is where the theory becomes interesting, even when the evidence remains thin. Not because it proves visitors, but because it shows how myths are reclothed by each age. A medieval reader might see angels. A modern reader might see astronauts. A future reader may see something else entirely, some technology not yet ordinary to us. The story persists, while the costume changes. There is a caution here, and it is worth keeping close. Ancient astronaut claims have sometimes leaned on a careless assumption that people in the past, especially non-European peoples, could not have built their own monuments or developed complex knowledge without outside help. That assumption is not a harmless shortcut. It strips craft, planning, experiment, and inherited skill away from real human communities. Many of these places are connected to living cultures, regional histories, and descendants who do not need their ancestors' work explained as alien intervention. A skeptical reading does not have to be smug. It can simply be tidy. If a stone wall can be explained by quarry marks, tool wear, unfinished blocks, local labor, and comparable construction methods, then the alien explanation has extra weight to carry. It must explain not only the wall, but why the ordinary evidence points so strongly toward human hands. The burden grows heavier, like adding stones to a basket. And yet, some accounts do leave a strange aftertaste. Not proof, more like a pause in the record. A carved figure with an unusual headpiece. A mythic teacher arriving from the sea. A painted being surrounded by stars. The difficulty is that symbols are not machines with labels stamped on them. A halo, a mask, a crown, a bird costume, a spirit body, a ritual garment, and a space helmet may share a silhouette. Similar shapes do not always mean the same cause. What we cannot know, in many cases, is how an original audience felt when they saw these images. We may have the stone, but not the song. We may have the carved surface, but not the voice that explained it to a child sitting nearby. The record often breaks at exactly the point where certainty would be most convenient. That incompleteness may be part of why the ancient astronaut idea keeps returning. It places modern loneliness into old stone. It asks whether humanity was ever alone, whether someone came down, taught us a few things, and left before the paperwork could be properly filed. There is a faintly bureaucratic comedy in that thought. Interstellar visitors crossing impossible distances, then leaving us with ambiguous carvings and no clear manual. If they came, they were not very good archivists. More likely, The theory tells us about pattern making. Human beings are exceptionally good at connecting marks. A triangle becomes a mountain, a pyramid, a signal. A line across desert becomes a runway. A mythic descent becomes atmospheric entry. This ability is useful. It lets us track animals, read weather, build calendars, and notice when a tool has been moved from where we left it. But it can also carry us a little too far, especially when wonder is involved. The useful thing to remember now is not that every mystery should be flattened into a practical explanation. Some mysteries deserve room, but room is different from surrender. We can admire the pyramids as human achievements and still feel their strangeness. We can study Nazca as landscape, ritual, and geometry without draining away its spell. We can read old stories of sky beings as theology, poetry, memory, and metaphor, while quietly noting how easily our century turns them into astronauts. So the traces in stone and story remain suggestive, but not conclusive. A carved face may be a mask. A great line may be a road for ritual walking. A monument may align with the sun, because the sun was already the largest clock anyone had. And somewhere in the margin of the open book, near a photograph of a weathered figure with eyes too large for comfort, the question stays penciled in lightly. Did visitors leave hints in the deep past, or did we learn to see visitors wherever the past becomes difficult to read? The stone does not answer. It only keeps its surface, grain by grain, while our explanations pass over it. This chapter focuses on the Drake equation. The Drake equation is a way of estimating how many communicating alien civilizations might exist in our galaxy. It was created to give a very large question a set of smaller handles. Instead of asking all at once whether we are alone, it asks what has to happen, step by step, for another civilization to be out there and detectable. Frank Drake introduced the equation in 1961 around a small scientific meeting at the National Radio Astronomy Observatory in Green Bank, West Virginia. That detail matters, I think, because the equation was not born as a grand announcement to the world. It was more like a working agenda, a way to organize a conversation among astronomers, physicists, biologists, and engineers who were trying to discuss a question so large that it could become meaningless if no one pinned it to the table. On a desk, it can look almost modest. A pad of paper, a sharpened pencil, a slide rule perhaps, with its cream-colored scales and little transparent cursor, a few letters written in a row. N equals R star, multiplied by FP, multiplied by NE, multiplied by FL, FI, FC, and L. The symbols look clean. The pencil marks may be smudged by the side of a hand. And then, behind those neat letters, the whole Milky Way begins to rustle. The first part, R star, is the rate at which suitable stars form in the galaxy. In plain terms, it asks how many new suns are being made. Stars are not rare, but not all stars are equally useful for this question. Some burn too violently. Some live too briefly. Some sit in crowded or unstable neighborhoods. So the equation begins not with aliens, but with stellar housekeeping. How many decent lamps are being hung in the dark? Then comes FP, the fraction of those stars that have planets. This term has changed in tone over the decades. When Drake first wrote the equation, Planets beyond our solar system were still hypothetical. Astronomers could suspect them, reasonably, but they had not yet counted them by the thousands. Today, thanks to careful surveys and patient instruments, we know that planets are common. Some are huge and close to their stars. Some are rocky. Some cross in front of their sun so slightly that a telescope reads the dimming like a tiny hesitation in light. What I find interesting is how this one term moved from guesswork toward evidence. Not certainty exactly, but firmer ground. The universe did not become less mysterious when exoplanets were found. It became more crowded. That is a different kind of mystery, and maybe a more unsettling one. Next is NE, the number of planets per star that might be suitable for life. This is where the arithmetic becomes softer around the edges. Suitability is a practical word, almost a real estate word. It suggests temperature, liquid water, chemistry, stable orbits, atmospheres, geological cycles, perhaps a magnetic field, though the requirements are debated. A planet may be too hot, too cold, too dry, too exposed, too young, too battered, or merely unlucky in some way we do not yet understand. A calm diagram of the equation would go like this. Stars are the input. Planets are the next filter. Habitable conditions narrow the pile. Life narrows it again. Intelligence narrows it further. Technology narrows it once more. Then communication, and finally time. At each step, the number can shrink a little, or a great deal. The output is N, the number of civilizations in the Milky Way that might be sending signals now, in a form we could notice. That little word, now, does a surprising amount of work. A civilization might have transmitted radio waves 1 million years ago. Another might begin 1 million years from now. Across galactic time, two civilizations can miss each other very politely, like neighbors leaving notes on doors at different centuries. The middle terms are the most delicate. FL is the fraction of suitable planets where life actually appears. FI is the fraction where intelligent life develops. FC is the fraction where that intelligence produces detectable communication. These are not numbers we know. We have one confirmed example of life-bearing, technological intelligence, and that example is us, sitting here with radio telescopes, coffee-stained lab notebooks, aluminum antenna dishes, and a fairly recent habit of wondering who else is awake. There is a small irony in using one planet to estimate a galaxy. It is not wrong to try. It is just a little like tasting one spoonful of soup and being asked to describe every kitchen in a city. A sensible person can make notes, but a sensible person also keeps the pencil light. If you're still up and listening, feel free to like and subscribe. Topic requests are welcome below. The final term, L, may be the most haunting. It stands for the length of time a communicating civilization remains detectable. This could mean how long it uses radio, how long it wants to be heard, how long it survives its own inventions, its weather, its politics, its appetites, its bad wiring, its good intentions. L is where astronomy quietly becomes sociology, engineering, and philosophy. A metal radio dish can be measured. The lifespan of wisdom is harder. And here is the brief stray thought, because numbers sometimes invite them. I once found an old pocket calculator in a drawer at a library sale, the kind with a faint green display and rubber buttons that had gone slightly shiny from other people's thumbs. When I pressed 8, it made a softer click than the other keys, as if 8 had been used more often, or regretted more often. For no good reason, the little screen showed 0. 0002 before I cleared it. Probably a failing circuit. Probably nothing. Still, it felt like the machine had been quietly estimating something in the dark for years and had finally been interrupted. Back to the equation. Its power is not that it gives a single reliable answer. In fact, depending on the values chosen, the result can be enormous or nearly 0. With optimistic assumptions, the galaxy may contain many civilizations capable of contact. With cautious assumptions, we may be alone for all practical purposes, or separated by such wide intervals of space and time that the distinction becomes blurry. This is why the Drake equation is sometimes misunderstood. It is not a detector. It does not prove that anyone is out there. It does not rescue us from uncertainty. Its usefulness is more modest, and to me, more elegant. It shows where our ignorance sits. It labels the blank spaces. Before the equation, the question could feel like fog. After the equation, the fog has shelves in it. One shelf for star formation, one for planets, one for chemistry, one for life, one for mind, one for tools, one for duration. You still cannot see to the far wall, but at least you can stop bumping into the same chair. Some terms have improved with observation. Exoplanet science has made the planet fraction less mysterious. Telescopes, spectrographs, and transit surveys have brought real data into a place that once held mostly educated speculation. Other terms remain stubbornly unknown. We do not yet know whether life emerges easily when conditions are right, or whether Earth was the beneficiary of an improbable chain of accidents. We do not know whether intelligence is a common direction for evolution, or one narrow branch among many, interesting mostly to itself. That uncertainty is not a failure of the equation. It is the point of it. A good framework does not always answer the question. Sometimes it prevents the question from dissolving into mood. I rather like that. There is a plain usefulness in a row of variables. The way a carpenter's ruler is useful even before the wood is cut. The equation also changes how alien contact feels emotionally. Without it, the idea of extraterrestrial civilization can drift into fantasy or fear very quickly. With it, the question becomes slower. How many stars? How many planets? How much time? How long does a species continue to speak into the dark before it changes its method, loses interest, grows quiet, or becomes something we would not recognize as technological at all? A civilization might not use radio for long. It might turn to tight laser beams, buried fiber, quantum systems, or communication methods that leave no broad, leaky signature. It might decide that broadcasting is unwise. It might not think in ways that make messages important. Or it might be very talkative, but across a gulf so wide that its signals arrive as a thin scratch of energy in a receiver. almost indistinguishable from noise. That is where this chapter brushes against the next idea, the mystery of a brief signal that seemed for a moment to say something. But the Drake equation stays with the counting before the listening. It asks us to prepare the ledger before we interpret the whisper. In the end, the equation is less like a prophecy and more like a carefully ruled notebook page. It holds hope without making a promise. It allows wonder to sit beside arithmetic. The numbers can be adjusted, argued over, erased, written again. A bit of graphite collects near the edge of the paper. The slide rule goes back in its. This chapter focuses on the wow. Signal, a fleeting whisper. The wow. Signal, a fleeting whisper. Is what was that unexplained burst of radio in 1977? It existed because a strong, unexplained radio signal lasting 72 seconds. The useful thing is to understand the ordinary pressure underneath it before the details start to pile up. This chapter focuses on the wow signal. The wow. Signal is a strong, unexplained burst of radio energy detected in 1977 by Ohio State University's Big Ear radio telescope. It mattered because Big Ear was doing the patient work of listening for narrow radio signals from the sky, the sort that might, in theory, stand out from natural cosmic noise. For people searching for signs of intelligence beyond Earth, it became one of those rare moments when the machinery seemed to lean forward. The object at the center of the story is not a glowing spacecraft or a witness account on a lonely road, but a strip of computer printout, faded paper, blocky characters, a red circle. In the margin, a handwritten word with an exclamation point. Wow. That small human mark is part of why the signal has lasted so long in memory. The data itself was spare and technical, but the reaction was not. Someone who understood the numbers looked down at the page and for a moment became less like a scientist sorting records and more like a person finding a strange footprint in damp soil. The Big Ear telescope stood near Delaware, Ohio, on land used by Ohio State University. It was not a dish that turned gracefully to follow a target across the sky. It was a large, fixed radio telescope, built from metal structures and reflecting surfaces, letting Earth's rotation carry the sky through its listening beams. That is a wonderfully practical arrangement, and also a limitation. You do not chase the heavens with it. You let the heavens pass over your instrument, like mail sliding through a slot. In August of 1977, Big Ear was part of a search for signals that might be artificial. The reasoning was fairly simple, though the engineering was not. Natural radio sources tend to spread their energy over broader ranges of frequency. A transmitting civilization, if it wanted to be noticed, might send a narrow band signal, concentrated and clean, like a flute note against wind in trees. One especially interesting region is near the 1420 megahertz hydrogen line, associated with neutral hydrogen, the most common element in the universe. Some researchers have imagined it as a kind of shared landmark on the cosmic radio dial. On August 15th, Big Ear recorded something unusual in that neighborhood. The signal rose above the background, grew stronger, then faded away, matching the way a fixed telescope would see a point in the sky drift through its beam as Earth turned. The whole event lasted about 72 seconds, which was the length of time Big Ear could observe a given spot passing through its field of view. That detail matters. A 72-second signal does not necessarily mean the source transmitted for only 72 seconds. It means the telescope saw it for that long. The source may have continued. It may have stopped. It may have been a momentary flash of something we still do not understand. The instrument, like any instrument, only had its little window. The famous code on the printout was 6EQUJ5. It was not a message in the ordinary sense. No alien sentence. No coordinates spelled out for us. The characters represented signal strength, with numbers and letters used to show how far above background noise the reading had climbed. The U was particularly strong. It was the kind of mark that would make a careful reviewer pause, not because it explained anything, but because it did not fit comfortably among the rest of the routine data. Jerry Amon, the astronomer who later reviewed the printout, circled the code and wrote, "Wow," beside it. I find that little word almost perfect. Not too grand, not a theory, just an honest notation from a person who had spent enough time with ordinary paper to recognize an extraordinary line. If this is useful tonight, saving it for another night is more than enough. The frustrating part came afterward. Researchers looked again and again. They searched the same region of sky, generally associated with the constellation Sagittarius. They checked for a repeat signal. Nothing of the same kind returned. This is where the wow signal becomes less like a discovery and more like a small locked drawer. A strong signal was recorded. It seemed to come from the sky. It had the kind of narrow band character that made it interesting to SETI researchers. But without a repeat, it could not be confirmed in the satisfying way science prefers. One event can be suggestive. Two events begin to look like a pattern. Many events let you build a map. The wow signal gave us one clean tap on the wall, and then silence. Several explanations have been proposed. One possibility is that it was a transmission from an extraterrestrial technology, though there is no solid proof of that. Another is that it came from some natural astronomical source not yet fully understood. Some have suggested human-made interference, though the frequency range was one where ordinary terrestrial transmissions were discouraged, and the signal's behavior seemed consistent with a source moving through the telescope beam from the sky. Later ideas have included comet-related hydrogen emissions, but those explanations remain debated and have not settled the matter for everyone. If this helps you rest, you can always come back to it another night. Equipment error is always worth considering too. I have a soft spot for unromantic explanations, partly because machines are very good at humbling our stories. A loose connector, a processing quirk, a stray reflection, an assumption built into a system years earlier. These can all produce ghosts. But in this case, no simple equipment glitch has become the universally accepted answer. The record is too interesting to ignore and too thin to crown. That is the odd balance of the wow signal. It is one of the strongest candidates in the history of radio searches, and also one of the least cooperative. It refuses to become either a confirmed message or a clean mistake. The printout itself helps keep the story grounded. This was not a cinematic moment of alarms and flashing panels. It was data reviewed after the fact, on paper with a slightly bureaucratic personality, the sort of paper that folds at perforations, the sort that makes a dry rasp when pulled from a stack. A radio telescope listened. A computer reduced the listening to characters. A person marked the page. Input, process, output, uncertainty. That chain is beautiful in its modest way. Cosmic possibility passed through antennas, cables, receivers, software, ink, and a human hand. At every step, something was translated. Radio energy became voltage. Voltage became numbers. Numbers became symbols. Symbols became a question. What makes this useful to remember now is not that the wow signal proves aliens. It does not. Its usefulness is more delicate than that. It shows how a mystery can be both technically specific and emotionally large. The signal had a frequency, a duration, a printed code, an observing instrument, and a patch of sky. Yet it also opened a space in the mind much wider than those facts. For a moment, the universe seemed less like a silent distance and more like a room where someone may have shifted in a chair. Then again, perhaps no one shifted. Perhaps a natural process, far away and unrecognized, brushed across the telescope's attention. Perhaps some local signal found an improbable path into the equipment. Perhaps the answer is ordinary, in a way we have not yet reconstructed. The evidence does not let us choose with confidence. That may be the honest place to leave it. In the long catalogue of alien theories, the wow signal is unusually restrained. It does not require hidden empires, buried cities, or travelers folding space. It asks only whether one brief radio event might have been more than noise. That smallness gives it strength. A single line on a page can sometimes disturb the imagination more effectively than 1,000 elaborate claims. And somewhere in the archive of this story, there remains that circled code, 6EQUJ5, with the red word beside it. A little astonishment in the margin. A practical scientist's note to himself, and accidentally to the rest of us. Not an answer, not quite a message, just a whisper that passed once through an Ohio telescope and did not pass that way again. Here we examine cultural echoes, aliens in art and imagination. Cultural echoes, aliens in art and imagination. Is how have stories of visitors changed our art and dreams? It existed because recurring motifs, abduction, contact, transformation. The useful thing is to understand the ordinary pressure underneath it before the details start to pile up. This chapter focuses on cultural echoes, aliens in art and imagination. In plain terms, this is the way stories and images of visitors from elsewhere keep returning in books, films, paintings, folk tales, toys, radio plays, and dreams. These images give people a usable shape for the unknown. They turn a blank patch of sky, or a strange light, or a private fear, into something with a face, a vehicle, a voice, and sometimes a rather impractical silver suit. A small stack of old science fiction paperbacks can tell the story surprisingly well. The spines are cracked white at the hinges. The cover paint has that slightly powdery feel, and the glue inside gives off a dry, sweet smell, like a used bookshop on a warm afternoon. On one cover, a saucer hovers over a city of glass towers. On another, a person in a helmet stands under two moons, looking very serious about a landscape that was probably painted in a hurry. These books are not evidence of alien contact, of course, but they are evidence of expectation. They show what a culture was ready to imagine when it looked up. Before the modern flying saucer, people had other vocabularies for encounter. In European folklore, one might meet fairies at the edge of a field, or hear of little people under hills, or speak of spirits that appeared at night, borrowed time, and left the witness unsure of what had happened. In religious art, beings from beyond the ordinary world arrived with wings, wheels, halos, rays, robes, trumpets, or flames. In many regional traditions around the world, stories of sky beings, ancestors, tricksters, and non-human persons are woven into living practices and local histories, not simply old curiosities in a museum case. It would be careless to flatten all of these into aliens. They come from different languages, rituals, landscapes, and obligations. Still, the resemblance in structure is hard not to notice. A boundary is crossed, a message is given or withheld. The person returns changed. Modern aliens inherit some of that older furniture and replace the rest. The fairy ring becomes the landing site. The enchanted hill becomes the hidden base. The shining messenger becomes the grey figure at the foot of the bed, or the tall mantis-like intelligence in a room too bright to describe. The costume changes with the century. Metal replaces mist. Laboratories replace groves. The witness is no longer handed a charm or a warning from the old world, but may remember a table, a humming wall, a smooth instrument, a white light with no visible bulb. What I find interesting is not that these accounts prove one another. They do not. It is that the human mind keeps building doors in the same parts of the house. Literature gave those doors hinges and handles. H.G. Wells made extraterrestrials a mirror for empire and vulnerability. Later writers made aliens into teachers, invaders, refugees, gods, parasites, lovers, bureaucrats, and incomprehensible neighbors. Octavia Butler used contact and transformation to ask what a human being is willing to trade in order to survive. Stanislaw Lem, in a different mood, imagined intelligence so unlike us that conversation itself begins to fail. That may be the more sober idea in the end. The alien who speaks perfect English is convenient for a story, but perhaps too convenient for the universe. Film added texture, the wobble of a model spacecraft on a wire, the painted stars on a studio backdrop, the glassy shine of latex skin, the low electronic note that seems to come from the ceiling rather than the speaker. A cinema alien is made from craft as much as concept. Someone has to sew the costume, solder the control panel, paint the crater, sweep the soundstage floor, and decide whether the creature's eyes should blink. I have a soft spot for that practical side. Even the strangest visitor needs a prop department. Fear and wonder often arrive carrying a clipboard and a roll of gaffer tape. The recurring motifs are fairly stable. Contact is one. A signal comes through. A light descends. A door opens. A figure appears at the edge of a road. Abduction is another, more anxious motif, filled with missing time, clinical rooms, and the uncomfortable feeling of being examined rather than understood. Transformation appears again and again. The human becomes altered, hybrid, enlightened, infected, chosen, or simply unable to return to ordinary life in quite the same way. Each motif handles a different pressure. Contact asks whether we are alone. Abduction asks whether we are in control. Transformation asks whether identity is as solid as it feels while making tea, buttoning a shirt, or finding the right key in a coat pocket. Radio and television carried these shapes into ordinary rooms. A voice in a wooden radio cabinet could make Mars feel close enough to interfere with supper. A black and white television set, with its rounded glass screen and warm dust smell at the back, could turn the living room into a receiving station. The alien was no longer only in a book or a painting. It arrived between weather reports, cigarette ads, test patterns, and the evening news. That mixture matters. Extraordinary ideas become more persuasive, or at least more memorable, when they share space with ordinary furniture. The visual language narrowed over time into icons. The saucer became a clean disc, often with a rim of light. The alien head became smooth, large-eyed, and almost childlike, though not quite comforting. The beam of light became a vertical column, a kind of elevator between worlds. The desert road, the cornfield, the military hangar, the bedroom window, the radar screen, the motel sign buzzing in the dark. These became cultural shorthand. A viewer sees them and understands the grammar before anything has been explained. And yet, there is no single alien story. That is the important part. Some aliens are warnings about technology. Some are hopes for rescue. Some are projections of colonial fear. Some are spiritual stand-ins wearing the clean plastic mask of the space age. Some are jokes. Some are nightmares with better lighting. Some are deeply lonely. The mosaic does not settle into one picture, and perhaps it should not. A single narrative would be too tidy for something that sits between astronomy, psychology, folklore, entertainment, and private experience. The evidence here is not evidence that visitors have come. It is evidence that the idea of visitors is useful to us. That usefulness can be noble, foolish, commercial, unsettling, or tender, depending on the decade and the person telling the story. A child's toy saucer made of stamped tin, a pulp magazine with blue-green ink, a museum painting of a heavenly messenger, a late-night film with a rubber creature stepping from a ramp. Each object carries a small answer to the same question. What might be watching from outside the circle of our fire? We cannot know whether the old stories and the modern accounts point to a shared external reality, a recurring structure in the mind, or simply the way culture teaches experience to dress itself. The record does not allow that kind of neat sorting. People see through the symbols available to them. A medieval villager, a 19th century spiritualist, a 20th century radio listener, and a modern witness staring at a phone screen may all reach for different words when something strange presses against the edge of perception. The part that feels strangely human is the need to make an image at all. We give the unknown a body because a body can be approached, feared, painted, doubted, loved, or placed on a paperback cover beside a badly proportioned moon. Art does not solve the alien question. It keeps it company. And as the next thought gathers itself, that may be one of the quieter reasons these stories endure. Not because they answer the sky, but because they let us sit with the silence without looking away too quickly. This chapter focuses on ambiguity and evidence. Ambiguity and evidence is the uneasy space between a strange claim and what can actually be shown. It exists because human beings notice patterns, tell stories, misread things, and also sometimes discover what earlier generations dismissed. It helps us hold a question without either swallowing it whole or throwing it away too quickly. By this point, many theories have passed across the table. Signals, visitors, hidden neighbors, altered states, old myths in new clothing. But here, the object is not the alien theory itself. The object is the table. A magnifying glass on a pile of photographs is almost too perfect an image, but it remains useful. Under the glass, a bright dot becomes a smudge. A sharp edge becomes a blur of silver grains, or pixels, or printer noise. The corner of the photo curls upward. A thumbprint sits near the margin. Someone has written, "Au summer," unknown object U on the back in blue ballpoint pen, which is not evidence exactly. But it is not nothing either. It is a small human mark trying to fasten a moment to paper before the moment evaporates. Most alien theories, especially the stranger ones, live in this zone. They are not supported by clear empirical evidence. That does not mean every witness is lying, or every story is foolish. It means the bridge between account and conclusion is usually too narrow. A light was seen, perhaps. A radar return appeared, perhaps. A person had an experience that felt more real than ordinary life. But the next step, from nothing happened to non-human intelligence was present. Is a long step across cold water. Evidence has habits. It likes repetition. It likes instruments that can be checked by other instruments. It likes timestamps, calibration logs, raw files, chain of custody, and the dull little labels on archival boxes. It likes when a camera lens is known, when the exposure is recorded, when the sensor has not been compressed into mush by a social media upload. This is not glamorous. A good evidence drawer is usually full of boring things: paper sleeves, staples, cotton gloves, an external hard drive with a handwritten sticker, a pencil sharpened down to a stub. Personally, I have a soft spot for this kind of boredom. It is one of the few forms of caution that has actually earned its keep. The process is simple in outline, even if difficult in practice. An observation comes in, a witness statement, a photograph, a radar trace, a soil sample, a fragment of metal, a strange audio recording. Then it is preserved, measured, compared, and tested against ordinary explanations first. Aircraft, satellites, balloons, sensor errors, reflections, lens flare, weather, human memory, hoaxes, and misidentified astronomical objects all stand in line before the extraordinary option. If those explanations fail, the result is not automatically aliens. The result is usually smaller and more stubborn, unexplained. That word carries more weight than it seems to. Unexplained does not mean impossible. It does not mean supernatural. It does not mean extraterrestrial. It means the available information has run out before the curiosity has. Some accounts simply stop there. A photograph without context is a little like a seashell found in a desk drawer. It may be real, but the shore is missing. Where was it found? Who picked it up? Was it collected after a storm? Bought in a shop? Inherited from someone, TM's aunt? Placed there as a joke? The shell itself has ridges, weight, maybe a faint chalky smell. It can be examined, but its story has partly detached from it. Many UFO cases have this same problem. The object is presented, but the path by which it arrived is foggy. This is where imagination enters, and imagination is not the enemy. It is the faculty that lets a scientist form a hypothesis, a child name a constellation, and a witness reach for language when ordinary categories fail. The trouble begins when imagination is asked to do the work of measurement. It can point toward a question. It cannot, by itself, answer it. Hope does its own work too. For some people, alien theories carry the hope that humanity is not alone. For others, they carry a darker comfort, the idea that chaos has a hidden author, that history is not merely accidental, that someone, somewhere, knows what is going on. I find that part strangely human. Even a frightening explanation can feel preferable to no explanation at all. A sealed door is unsettling, but an endless hallway is worse for some minds. Skepticism, at its best, is not contempt. It is a slower way of handling fragile things. A skeptical investigator does not need to sneer at the witness, any more than a careful carpenter needs to insult the wood before measuring it. The practical judgment is the same. Measure twice, cut once, and try not to build a cathedral on a warped plank. That may sound a little severe, but with extraordinary claims, the plank matters. Still, there is a quiet irony here. Many discoveries began as anomalies. Meteorites were once doubted by some scholars because stones falling from the sky sounded absurd. Continental drift was not embraced immediately. Ball lightning remains difficult to study because it arrives rarely and does not make appointments. The world has a way of embarrassing certainty on both sides. Too much belief makes the mind sticky. Too much dismissal makes it brittle. Science is often described as a body of knowledge, but that is only half true. More deeply, it is a method for being less wrong in public. A claim is made. Someone else checks it. The instrument is tested. The sample is retested. The result is published, challenged, revised, or discarded. The process has paperwork in it, and awkward meetings, and people arguing over units, and someone discovering that the cable was loose. The cable being loose is, in my opinion, one of the great unsung characters in the history of knowledge. This matters for alien theories because the stakes are so large. If convincing evidence of non-human intelligence appeared, it would not need theatrical language. It would need careful handling. The first reliable sign might not look like a saucer over a cornfield. It might look like a spectrum with an odd chemical signature, a repeated signal with structure, a material whose origin can be traced and tested, or a biological pattern that does not fit known evolution. It might arrive as a spreadsheet before it arrives as a revelation. And yet, the human mind is not a spreadsheet. It dreams, fears, compares, remembers badly, and notices too much in the dark. A person standing in a field at night, hearing insects in the grass and a distant road ticking with tires, is not a laboratory instrument. Their body is part of the event. Their pulse, their expectations, the temperature on their neck, the story they heard last week, the bright planet low near the horizon, all of it enters the record. This does not make them useless. It makes them human. Ambiguity is frustrating because it refuses to finish the sentence. It invites exaggeration and fatigue. It can be exploited by grifters, polished into content, or used to make weak evidence seem profound. That deserves caution. But ambiguity also keeps a little room open. It reminds us that not knowing is not a failure of intelligence. Sometimes it is the only honest position left. The quiet weight of oh, maybe oh is that it asks for patience without promising reward. Maybe the universe is crowded and hidden. Maybe it is sparse. Maybe some witnesses have seen unusual atmospheric effects, or secret technology, or misremembered light, or something not yet named. Maybe the old stories and the new sightings share more psychology than physics. Maybe a few cases contain a hard kernel that has not yet been cracked. A file remains on the desk. A photograph remains under glass. The pencil note on the envelope is fading, and the evidence is not enough. Not enough to believe. Not enough to forget. That is where many of these theories rest. For now. In the margin between wonder and proof, carrying the small, persistent weight of maybe. This chapter focuses on the comfort of cosmic curiosity. Cosmic curiosity is the habit of wondering about the universe without needing every question to close neatly. It gives people a way to live beside incomplete maps, strange reports, unanswered signals, and theories that may be wrong, but still reveal something about how we think. It does not solve the alien question, exactly. It gives the question somewhere to rest. After all the paradoxes, hidden visitors, ocean lights, folklore echoes, and careful doubts, the useful thing may be this. Not knowing is not always a failure. Sometimes it is simply the honest shape of the evidence. A notebook can have blank pages without being a bad notebook. A sky chart can show labeled stars and still leave most of the black paper untouched. On a desk, this kind of curiosity looks surprisingly ordinary. A closed journal with a cloth cover. A pen laid across it at a slight angle. A smudge of graphite near the edge of a page where someone changed their mind. Maybe a library receipt folded in half, listing a book on astrobiology, another on folklore, and because people are rarely tidy categories, one on deep-sea geology. I like that mixture. It feels truer than a perfect shelf. The odd thing is that cosmic questions often return us to small objects. A radio telescope is enormous, but it depends on bolts, bearings, signal cables, cooling systems, maintenance logs, and someone with a thermos walking through a control room at an inconvenient hour. A spacecraft photograph may look like pure wonder, but it arrives through lenses, sensors, calibration charts, error correction, and patient people squinting at pixels. The universe becomes thinkable through tools that can be dropped, scratched, mislabeled, or left under a stack of papers. That is a useful correction to the mood of alien speculation. The subject can become grand very quickly. Civilizations, dimensions, hidden oceans, ancient stars, cosmic silence. But the actual work of wondering is usually modest. Someone compares timestamps. Someone checks whether a reflection could have come from a window. Someone listens to an old recording with headphones that pinch a little after an hour. Someone says with less drama than we might expect, "Oh, not sure. That phrase may be one of the best tools we have. Not as an escape, and not as a way to dismiss everything. More like a small brass weight on a measuring scale. It keeps the mind from tipping too far towards certainty. Whether that certainty says, "Oh, aliens are here," or "Nothing strange ever happens." Both positions can become a little too comfortable if held too tightly. The record, when handled carefully, is more uneven than that. Some accounts are mistaken. Some are shaped by memory, weather, instruments, expectation, fear, sleep, culture, and the plain awkwardness of being human. Some may describe events that are not yet well understood. A few simply stop at the edge of available evidence, like footprints ending at a gravel road. It is difficult to know what to do with those. I tend to think they should not be worshipped and should not be thrown away too quickly either. There is a middle shelf for such things. Cosmic curiosity belongs on that middle shelf. It is not belief, exactly. It is not disbelief either. It is more like keeping a clean work table. You leave room for the ruler, the old photograph, the star catalogue, the witness statement, the skeptical note in the margin, and the coffee cup that should probably not be so close to the documents. A practical person moves the cup. A curious person keeps reading. In the history of astronomy, this balance has mattered. People once traced constellations with stories because stories were a way to remember patterns in the sky. Later, observers used polished metal mirrors, glass lenses, photographic plates, radio dishes, and digital arrays. The method changed, but the posture remained familiar. Look carefully, compare, wait, revise. The sky does not explain itself just because we ask politely. It gives light, delay, noise, motion, absence. We make instruments, and then we argue about what the instruments mean. That argument is not a flaw in the process. It is part of the process. A signal has to pass through atmosphere, hardware, software, and human interpretation. Input, process, output, limitation. A flash becomes a measurement. A measurement becomes a graph. A graph becomes a possible explanation. Then the explanation meets other explanations, and most of them fail. This can sound discouraging, but I find it strangely comforting. Reality is allowed to be difficult. We do not have to pretend the first answer is the final one. The same is true of the stranger theories we have passed along the way. Many of them lack solid proof. Some are better understood as mythology, metaphor, misidentification, or social anxiety in unusual clothing. But even then, they are not empty. They show where the mind reaches when it meets the unknown. Across time, people have imagined watchers in the sky, beings under hills, lights over water, messengers from other realms, clever little figures at the edge of ordinary sight. The costumes change. The old question remains. What is out there? What is in here? And why do the two sometimes feel so close together? That question is not a problem to finish before sleep, or before morning, or before the next generation of telescopes lifts into a colder orbit. It can remain open. In fact, it may be better that way. A sealed mystery becomes a possession. An open one becomes a horizon. You cannot put it in your pocket, which is inconvenient, but also rather healthy for the imagination. There is a small humility in looking up. Not the theatrical kind, not the kind that announces itself. Just the ordinary realization that Earth is a working planet with laundry lines, airports, pine needles, traffic lights, kitchen sinks, coral reefs, spreadsheets, and children drawing stars with 5 points, because that is the agreed shape, even though stars are not shaped that way. All of that is happening under a universe so large that our best questions still feel handwritten. And maybe that is enough for tonight. The value of curiosity is not that it guarantees an answer. It keeps the mind porous. It lets wonder and caution share the same chair. It allows a person to say, "Oh, this story is probably not literally true. Oh, and also, oh, something about it matters. Oh, that is a rare and useful combination. I wish we used it more often. If you return to these mysteries another night, they will still be here. The equations will still be unfinished. The ocean will still keep most of its darkness. The old reports will still sit in folders, creased at the corners. The stars beyond the window, whether hidden by clouds or visible in clean, cold air, will continue doing what stars do, without hurry and without explanation. So let the questions drift outward now, not as demands, but as points of light. Maybe life is common. Maybe it is rare. Maybe intelligence learns to hide. Maybe the universe is mostly empty, or mostly full in ways we have not learned to notice. We do not know. The page can close for a while. The pen can rest across the cover, and somewhere beyond the edge of the next thought, the mystery remains gently unresolved, waiting to be wondered about again.